All right. Good, good, good evening, everybody. So on with it. So I haven't met in a while here. I think I was checking my schedule here. There's been quite a number of issues happening here. But with that being said, I wanted to give you a heads up to say we are tentatively going to have an assessment. In an ideal case, I would have proposed that we have it next week, but I want to suggest that give you some 2 weeks to prepare. So we're going to have a test in the week of the 19th. I know it's a study break, but we'll try and see if we can have this test much earlier during the week. So possibly on the 20th or the 21st or something. I want to avoid a sort of situation where you're forced to prepare for the test as opposed to the final exam, ideally. And in terms of coverage, we're essentially just going to have, it's going to be an easy test, I think, because up to this point in time, we haven't really covered that much content. So content coverage is going to be everything we've looked at all the way up to the most recent module that we were looking at. I think it's module number 3 or something like that. Okay. Yeah. So the stuff that we've covered up until that would be module number. If I can just quickly check. Module number 3, ideally, right? Which is nothing more than just the knowledge discovery process. So it should be a fairly easy test. And then the other thing I'm going to do is, I think by the end of this lecture, we should be in a position to work towards, ideally in ideal cases would have been carved out as mini projects, if you will. But in essence, I'm just going to carve out problems that will require that you kind of just come up with a proposed solution. And then what we will do next week is we shall have you kind of like present these proposed solutions, ideally. This will all make sense when I make available the assessment specification. So in terms of assessments, that will be it. And we can proceed. So a reminder that I think when we met last time, we essentially had started our we are wrapping up our discussion of lecture series number 3 or module number 3, and so today we are going to transition to our discussion of module number 4, which is the data cleaning and text preprocessing process. Now, what you immediately begin to notice as we are going through this lecture series is that we've essentially doubled back. So we had a very broad, if you remember, we had a very broad discussion about the knowledge discovery process. But what we're going to do in this lecture series is we're essentially circling back to one of the earlier phases of the CRISP-DM methodology or approach. In as much as we are aware of the fact that there are a series of approaches or methodologies that can be employed, we did mention that we gravitate more towards the CRISP-DM methodology. Yeah. Anyhow, so it's going to be a fairly short lecture, and what I'll do is towards the end of this outline, because we've already set the stage for most of the things we're going to be discussing in here, we'll actually quickly go through a notebook which will be shared with you to go through as well. Okay. A reminder here that in our most recent discussion, we discussed these 6 phases of the CRISP-DM methodology. And as luck would have it, typically, not typical actually, we tend not to spend a lot of time on the business understanding and data understanding aspect of these 6 phases, simply because when it comes to business understanding, this is generally contextual. It would ideally depend on the type of problem that you're working on, the problem that you're addressing. And in fact, most of the things that you tend to do in the phase are really more aligned towards project management. And then if you remember our discussion of what typically happens during data understanding, you mostly would be dealing with issues on how exactly you're going to put together or how you're going to implement a computer program or scripts that will enable you to harvest information. Again, that is contextual. In this day and age, it's generally the case that you would have easy access to this information. So extracting this information would be as trivial as you pulling it from, let's say, a relational database management system, or if you are lucky, you could be pulling this information from, let's say, some API endpoint, for instance, right? So in most of these instances, actually, the data would actually be well structured such that it's a lot easier for you to actually collect or harvest the data, okay? So again, this is contextual, but what we're going to do in this lecture series is we're essentially going to focus on the data preparation kind of phase, right? So if you look at the title, we're interested in understanding how we go about cleaning the data and processing text ideally. And really, if we were to circle back and look at the broad activities that are performed as part of data preparation, we highlighted important things like data selection, for instance, right? So you get to decide exactly what sort of data you're going to include in the modeling process of your pipeline. You obviously will be dealing with data cleaning, or otherwise called pre-processing, right? Which is going to be the focus of this discussion. And more importantly, there's another crucial activity, right? It's a prerequisite to the modeling phase. So this notion that you'd have to transform the data somehow, in essence, converting it into a representation that the estimators will be able to, or a representation that estimators would be expecting ideally. Typically, these would be like numbers, right? It's numeric representation. There's other things that you do to sort of like prepare the data to the modeling phase. For instance, you'd want to integrate the data, and I think I had hinted at the fact that you'd actually be required to do this in most instances, because the information that you'd be working with would be coming from all sorts of different places. And if you remember the example I was giving for the data coming in from, when I say students at risk of failing project, we realized that most of what we were doing involved collecting data from a broad spectrum of places. So the learning management system, which is Moodle, we're getting data from the student information system, we're getting data from Google Forms, so it's a self-administered survey distributed to students and all those things, right? So in essence, the things that you do as part of data preparation ideally, right? And we outlined exactly specifics of these activities, what sort of things you tend to do, from data selection all the way up to formatting of the data here. Now, again, just to wrap it in here, that the data preparation phase is the precursor to the modeling phase, ideally. And our goal really, it turns out, right, our goal is to get this sort of representation, right? This is assuming you're working with text. This could just as well be images. It could be a broad spectrum of things here, but our goal is to get this sort of representation, do a bit of pre-processing, right, to come up with a different sort of representation of the same input, right? And what you begin to notice here is that there's some fancy things that we've done to the original input data. For starters here, it's evident that the relative size of this, well, this is textual input here has actually drastically reduced, is it? If you notice, and if you pay particular attention to the text itself, you begin to, by the way, this is not really complete per se, but if you pay close attention to the original representation of the text here and compare it with this intermediate representation after pre-processing, you begin to notice that there are very strange things we've done here. Like the word, thesis, the very first word here, was in all uppercase, and then all of a sudden it's in lowercase in this intermediate representation. The other thing that we've clearly done here is that if you look at the word thesis as well, we seemingly have eliminated some characters from the word thesis, is it? Specifically, we've eliminated the last S, right? I don't know how much of this you remember, but we had hinted at the fact that during our outline of the knowledge discovery process, we had hinted at the fact that some of the pre-processing operations that you perform on textual content, for instance, would involve lemmatization, and in this particular case, stemming. Is it you're ideally reducing the words to their root form? And more on that, actually, you see that it's a very easy thing to do. Those of you that are, I think it's people that are enrolled into the MSc in Artificial Intelligence, have a dedicated, I believe, course which is centered on natural language processing. So there's quite a bit of exciting things in store for you next term here. A lot of this will make logical sense. But anyway, so we're reducing the weights to their root forms, and then there's other things here, right? You notice that the second word, which is if the original representation, it's M. It's a Master of Engineering, right? Short notation of Master of Engineering. Then there's a equal sign, is it? Followed by the word abstract, and then there's a hyphen. If you compare the textual representation, I don't know if you can see this here, but maybe what I'm going to do here is just try and draw attention to what it is I'm talking about here. In essence, what I'm referring to is, if you look at this text here, this chunk of text here, right, and you compare this with the resulting representation, you notice that there's some things that we've done to this text, right? Specifically, we seemingly have omitted the M and the dot, right? And then after the ENG here, there's supposed to be an equal sign here, which again has been eliminated from the intermediate representation. In essence, what we're doing is we are performing pre-processing activities, right? And it turns out that there's a specific reason why we do these things, right? One of the reasons why we do this is to perform what's called dimensionality reduction, ideally. So this notion that typically one of the common ways of representing this intermediate representation after pre-processing into numeric form that the estimators will be able to understand, ideally involves building some sort of vector, if you will. Okay? Now, this vector will appear to be something like this, and there's a whole process that you follow to build this vector, right? A nice way of thinking about this vector is, I don't know if I mentioned this earlier, but a nice way of thinking about how you're building this vector is, you would remember that this original representation here is, it's an observation, is it? It's a record. Incidentally, this record is coming from here. It's one of many um, metadata elements. These are abstracts really. It's one of many abstracts associated with theses and dissertations. So in fact, what you are seeing here, the thing in red here, are the chunk of text that we are extracting. I'm just going to order these in descending order so that we start looking at the more recent uploads. Is it like this? I'll just open up a few, maybe 5 observations should be sufficient. I don't know, it should be sufficient here. So what you're seeing here, as an example here, are this chunk of text, right? So we go to this abstract and we extract this, right? The entire abstract. Of course, this has been loaded into a pandas data frame, right? So this would be like your very first record here. You know what I'm going to do here is just use some regex here so that I put this in one line here. So what we're doing here is we get this record. I'll call this record 1. Yeah. And then we do the same thing. We harvest the abstract associated with this dissertation, right? Of course, these have been loaded in. They've been loaded in the pandas data frame, right? I'm just gonna delimit them so that it's a lot easier for us to see the records here. Maybe a third one would help us understand what is going on. I guess I'll get these predictors of revenue tax collection here. Let's copy this cross and tag it as record 3 ideally. Again, because I'm using a regular expression here, could have done something much more sophisticated, but that's neither here nor there. So in essence, right, what we are doing in this example I'm giving is I'm showcasing the process you'd go through if you are working on a problem that involves working with this sort of text, right? So in this particular case, these are abstracts, but you know, this could just as well have been something else. Like this could have been social media posts. So let's say, you know, you've been hired by some political party or something to try and analyze posts that are being shared on the, I don't know, maybe on the UPND Facebook page or something. If they have a Facebook page, I have no idea if they do. What you would do is you would actually extract. You could view these records as being the posts themselves that are being made. I don't know if this is making sense here. I'm hoping that we can. It gets really interesting actually. It could be that, right? So it could be. Let's say and I've done this before, by the way, in the past. I've analyzed a post from HH's Facebook page, right? So extracting the posts, yeah. Extracting, it's quite interesting, especially that it's election year actually. Maybe people that are doing NLP next term, we can do this because I think I'm taking NLP here. So these records could just as well be these individual posts, is it? For in this particular case, because this post has a whole range of images, because you're interested in just analyzing the text, you just get this chunk of text. The other record associated with this sort of analysis would be this, which wouldn't be very useful here because this is, this chunk of text here, right? And the way you know that these are different is you can literally tie them to the IDs, right? Each post has a unique ID ideally, and other metadata elements like the date when it was posted and the usual stuff, right? This would be another record entry. Or it gets really interesting, right? You could be working on a problem that involves you analyzing the comments, right? Because if you're analyzing posts like from Zambian Watchdog, you'd be working on a problem that requires you to look at things from the perspective of the entity that publishes this post. One of the things you would be interested in doing is what sort of reactions are you getting from people that actually get to engage with the Zambian Watchdog, for instance. So your interest would be, well, I want to see, in terms of the engagement, I'm going to analyze the comments, right, that people are making. So relative to a post like this, I'm working on a problem that is going to involve analyzing, or comments here, analyzing these comments. So what you'd be doing here is you'd be getting, zoom in here, you'd be getting, your records would then be these comments, right? You get this comment, it becomes like a completely new record. So record number 1 here would be a comment by this person, Tiza Nyimbiri or something. The other, record would be this. Now, of course, we are overly simplifying things here, because it turns out that when you're analyzing this sort of text, there's auxiliary information that you'd need. Like in this particular case, I would need to keep track of maybe the user IDs associated with the people that are commenting. And I could make this more complex and say, well, in addition to the textual input here, like this, what I'm going to do is I'm also going to get the reactions, right? Or something. How many likes, how many replies, so it gets kind of complex here. But of course, you'd figure out how to implement such a thing. But the thing I was trying to drive at, the reason I'm talking about that is I'm saying what you're seeing here in this red bounding box could be something like this. In fact, there are these, right? These abstracts, text from the abstract. It should be not more than 500 words, right? So these are things that you're analyzing. And what we're saying is, for you to analyze these records, you have got to pre-process them and then you transform them or something. How do you pre-process a range of things that you're doing in terms of text? You discuss this in detail. You case forward, right? Instead of having thesis in all uppercase here, it's in all lowercase. You perform lemmatization, or you perform stemming. Yeah? Instead of using the word thesis in full, you just say thesis, right? And they're simple algorithms, really, stemming algorithms, a lot of them actually, that gets to do this for you out of the box, right? So you'll be seeing there are certain words that are kind of like stemmed in a certain way. Some of them may not be stemmed. Of course, you can modify these stemming algorithms that you'll be using, but usually using them in their vanilla form is typically sufficient. If you notice here, but where we have bandwidth here, you notice that instead of allocated or allocation or something, you have alloc or something, well, compute. So the word computer or computing is the same, right? Or computers, it's the same thing. Within the context of human language, may be different, but from the perspective of the computer, you can view these things as being literally the same, ideally. So a computer, computers, computing would be considered to be the same. Now, the reason you're doing this is so that you don't end up with a very large vector, because the way you build this vector, we get to discuss how we build this vector, but so you understand here, the way you build this vector is you're building it in such a way that you get all the records within the universe of the problem you're solving. So in this example of ETDs, right, abstracts, I would get all the abstracts here, this abstract, right? I know how this would be here, guys, space here, let me see if I can find, there we go. I just need to replace that. You get this abstract, you get this abstract, right? You get this abstract, and what you do is you're building this vector. So think about this vector as like a spreadsheet where the column names would be the unique words, if that makes sense, right? So what you'd have here would be the unique words. Now, you begin to notice that this is actually computationally expensive, right? I don't know if you're able to do this. So I'll just, I will do, maybe I can, I think I can though. I'll do, let's see if we can showcase this so that everybody is in the know in terms of what we are doing here, right? So it's say var record 1 or something, right? Record 1 is equal to this. var record 1 is this. And I will go get this and check it up as record 2 or something like that. I'll call this var record 2. What else? Of course, I mean, I wouldn't be manually doing it like this. I'd probably ingest everything in a pandas data frame, and then I'd be doing the sort of analysis I'm looking at doing in using a pandas data frame or something like that, right? So the idea here is, if you think about it, right, you have var record 1. You know what I'm going to do here? I'm just going to simplify things and just say I want to split these on a space, right? This is the simplest thing I can do here. It may not be fancy here because they're still kind of like, what do you call this? They're still special characters and all these things here, right? This chunk, but that's fine. So what I'm doing here is I'm saying I want to showcase what's happening by just tokenizing these things on a space character, ideally, right? So what I'll do is I'll say, I'll call this final vector. I'm running out of names here, vector. So that is a lot easier. I'll just call this to be an empty list or something like that, right? You should remember this. I don't know how much of this you remember. I guess you do though. So what I can do here is I can say, I'm going to say, okay, I'm going to say var record 1 dot split, right? I have this, and then I'm going to add this to var record 2 dot split, right? And then I'm going to add var, if you remember this, I don't know how much of this you remember, var record 3 dot split again. So that I'm combining, I'm just using the plus sign here to just add all of these different vectors into one, is it? And then I'll call the var final vector here. Just do this. So the thing here is that, you see, I have this vector here, right? Now, the vector comprises of all the, I know what this is here, but the vector, so the vector I've created right now, right, is like I've strung together, or rather I've created a list that comprises of 1022 unique words, not unique words, 1022 words coming from the 3 documents. This could have been, let's say, all the 5,000 plus documents, right? Because the number of ETDs that we have in the user repository are about 5,000 or so. These things here. And I'm going to use this as an example, by the way, so I might as well go here. This, if you notice, the total number of records we have in the UNZA repository, masters and PhD dissertations, are 5,725. So it would be like 5,725 are the things that I'm analyzing. And so what we're saying is the reason you're analyzing, I'm trying to showcase why this is important, if this is making sense. And I don't know if maybe I can maybe I can create a pandas data frame or something from this, but I don't know if this is even important or something like that for the purposes of this example. It would have been nice if I could showcase this, I guess. Let's see here, import. Okay, I'll showcase this later on. But the thing here is that the reason why you want to perform all of these things like stemming and stuff is because for now, right, working with just three records or 3 observations, I can convert this back to a list, is it? Final vector unique. So the length of the vector that has all of those terms, right, from the 3 observations is 1022. But if I get the unique entries, right, I don't know if you remember this here. I'm just using the native, data structures, right? I'm converting it to a set because the set has that nice property where it only stores unique entries, right? And then I convert it back to a list or something like that. So if I check the length of the unique entries for a vector here, you notice that in the example I'm illustrating, where I have 3 documents, the number of unique words, these words here, are 511, right? And it turns out that these 511 are used in such a way that you string them together. What you're seeing here as BOV, absent, absent, abstract, abas, and stuff, these actually represent unique words, right, in your corpus ideally. Yeah, so I mean, we can convert this if you remember our pandas here, right? Import pandas as PD. I don't know how much of this you remember here, but I'm going to say var final vector unique, I'll call this df or something, is going to be equal to pd dot data frame, and then I'm going to get var final unique or something like that, I don't know, and then I'm just going to say this is going to be equal to, I don't know how much of this you remember, you guys, but I'll call these ETD abstracts or something like that, so that if I check this data frame, if I check the column, it's just one column, right? So what I'm trying to say here is, I can transpose this, is it, right? If this is making sense, no, just the way it is fine. Just the way it is fine. I can always transpose it. But anyway, so the point I'm trying to put across here is that I've really messed it up here. It's fine. I can use this just the way it is. It's like you're getting all of these words. You're stringing them together, right? You get collected, and but guys, why not do this? We want to showcase this. I don't know if Excel or LibreOffice thing is going to handle this here. Maybe it will, maybe it won't. I don't think anybody cares, but let's see if we can just replace the square bracket here with not plain text here, and replace that. And then also the single quotes here, I'll replace them with nothing at all. Then what I'll do is, I'll copy this, and then I will, I will then do a text to columns or something, comma, right? So what you're doing, right? I don't know if this is making sense here. So I'm just going to go to the end here. Wow, there's even... So what you do is, this thing even has spaces. Not that it matters here, but there are even spaces here, because we haven't done the usual stuff that we do here. You can always transpose these, I guess, right? And then I don't know if this thing is gonna. We're doing all sorts of weird things. You're going around in circles here. That's fine also. And then I can just sort these. Arrange as labels, X. There we go. So I'm going to do that, right? And then starting from here, copy this, and then also just kind of transpose it back. We're doing a whole range of things here. So in essence, right? I'll call this ID or something. So we could have something like record 1 here, record 2, record 3 or something like that, right? Now, if you think about it, right, in the example I've just given where there's just 3 records, I've created a vector with how many I don't know how many. I've created a vector with how many words are these? There's a row here. How many terms are these? I don't know if you can see here. 511, right? And the count here. There's 511 of them. right? So as your corpus grows in size, this vector also grows, is it? In fact, you want to think about UNZA, for instance, right? As an example. It's like there are people doing chemistry, history, languages, computer science, chemistry, physics, and each of these different disciplines, mines, I guess, mining engineering, geomatic engineering and stuff, agricultural sciences, all of, I guess, public health also and medicine, but all of these different disciplines have their own, I want to use the word vocabulary here. And so as you are compounding, if you're analyzing that type of text, what you have is a sort of situation where this vector here that I'm scanning through here is going to have much, much more than the 511 words I have here. These. It will be much larger, right? And guess what? We'll discuss this again, I guess. But the way you implement this is you don't just work with these are called unigrams, right? Individual tokens, but rather you combine words, right? So experimentally you begin to realize that using trigrams or bigrams may be beneficial to you than using unigrams. So if you're using bigrams, what you're saying is that given this sort of text here, remember I'm tokenizing by space, right? Space, and we'll talk about this next time. Using unigrams, I'm just looking at Zambia's as a separate entity, re-entry, policy. These are all separate entities, right? Or separate tokens. But when you're using bigrams, it's like you're first of all going to look at individual words and then you're combining two words. So it's like Zambia's re-entry will be considered a single entity. Re-entry policy will be a separate entity as well. So the moment you have a combination of single words and two words, bigrams, this vector grows in size. It should no longer be 511. In fact, if I was to use count vectorizer and showcase this, and we get to discuss this later on, you begin to notice that the total number of tokens that I'm going to have here are not going to be 511. You know, if I'm using trigrams, it's even worse, right? Because I'm going to have a combination of single words, two words, and then three words. And the idea behind that is you're saying, well, if you're working with text from the University of Zambia, for instance, something like University of Zambia is supposed to be considered as a single entity, right? Three words here. University of and Zambia. Right? Republic of Zambia. You know, computer science, right? If you computer science or artificial intelligence. If you just look at these as unigrams, it won't really make a lot of sense, right? Like it's just artificial would be considered, you know, distinct from intelligence. But if you're using bigrams, you begin, oh, artificial intelligence, and then, you know, and we'll talk about this, I guess, during text processing. But the thing here is, if we are saying that this becomes expensive when you're working with text, right? By the way, this is a Zambia nation here. These are bigrams, is it? Yeah, Zambia object, you know, Zambia studies, Zambia this or whatever, Zambia use. Some of these, like combination of two words, may not really make sense, but you don't care about that. The machine, just throw it at the machine, really, right? And the machine or the estimator will know exactly what to do, really. But you begin to notice here that if this vector grows in size, depending on how complex your vocabulary is, then it makes sense that we start excluding some useless things from here, right? Like already here, right? These numbers here, like negative 35 or negative 20, why would you want to build this long vector, something similar to this, that will have a negative 35? It's not going to be useful for you, right? Or why would you want to build a vector? In fact, you wouldn't really want to build a vector for this, but I'm going to showcase this, right? Or if you have a situation like this, right? Look at this. I don't know if I'll be able to see this, but maybe not. I want to circle out some things here. I'll probably use red here. I'm looking for something that has a common. Look at this. Internet, right? This internet and goodness, I saw the internet and this internet here. You know, if I am to check these unique entries here, right, guys? Vector unique. And I go to where, because these are ordered in, I think in alphabetical order, I think so. If I go to where internet is here, no, they're not. But we know, we discussed sorted, is it? If you remember that. Right, so if I don't know if you remember these inbuilt functions here. These are sorted here. If I go to where the eyes are, guess what? But where is the internet here? I don't know why the internet is okay, it's a horrible example. The example I have in this I'm sorry. The example I have in the slides is different from here. I'm trying to see if let me see if I can find birth or something. I want to showcase something birth. Okay, just two. How about a go? One. I'm looking for a word that. How about Zambia? A word that is going to be common. Beautiful. If I check for where Zambia is, right? You see, we have Zambia here. There's Zambias here, right? I don't know where else Zambia is here. There's another Zambian here, right? There's another Zambia up on top. Now guess what? If I start checking for Zambia right at the bottom here, where is Z? This is horrible, and I can't find Zambia again. Oh, it's uppercase, so it's, look at this. The way I'm sorting, I'm kind of creating my corpus, if you will, has resulted in a case where this Zambia is considered to be different from Zambia's. But we know that, so these are like considered separate, right? But we know that these are the same thing. This word here is exactly the same as this. It's Zambia's, Zambia, right? You know, if that Jones or John is the same thing here, right? So this is the reason why one of the things you may want to do is to remove these things here, like punctuations, for instance, right? In fact, it's one of the reasons why you have to perform these other preprocessing operations here, like case forward here, because if you don't case forward, the word Zambia, this is going to be considered different to this. It will be different from this, right? Which is not true. These are the same things here, right? Or it will be considered different from Zambia's. That is not true. These are the same things here. So you perform these processing tasks. But anyways, and the reason you're doing this is you're trying to reduce this vector that you're going to be working with, right? So that it's not computationally expensive for you to do the things here, right? Now, it turns out, in as much as I've been focusing on text here, it turns out that there are different types of data types that you find yourself working with. Okay, so I was giving an example of text here, but it's entirely possible that you will find yourself working with textual content here that will have weird attributes like this, right? I'll just say student here, student 1, 2, 3, 4, 5 or something. Yeah, have something like gender or something, right? This is female, male, female, male, or something like that, right? What else? You can work with text here that will have something like experience, right? Programming, I guess, I don't know. Programming experience, or Python, programming, Python though. Python programming experience. So maybe let's say it's on a none, little, so it's just very low, just very low, low, very high, 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 right? Now what you begin to notice here is, and maybe you could have some other text here, what you begin to notice, the point I'm trying to put across here is that you typically would find yourself dealing with a broad spectrum of data types. Okay, if I had motivation or something, I love computers or something like that, and then I want to work in the tech sector or something like that. I'm just assuming here I like to program or something. Program. I want to be a developer or something like that. And then I want to work as a programmer or something. Now here's the thing, right? If you look at this, what I was just from walking you through in terms of the three records here falls under the broader category of this type. It's similar to this. It's textual input, right? Textual content. But you begin to notice that when you're dealing with, maybe I also have age here, right? I don't know, maybe this is like 18, 20, 22, 21 or something like that, right? And it turns out, right, this data type is different from this, right? These are like categories, right? They're discrete values ideally, is it? These are also categories as well, but different types of categories where order matters. In this particular case, it doesn't matter whether you're male or female. I mean, there's a difference, quite right, but there's nothing like a female is better than a male or something like that, right? Doesn't exist, and these are numeric entities. The point I'm trying to put across here is that when you're working with data, you typically find yourself working with a broad spectrum of data types, or you find yourself working with data that is associated with different types of attributes, characteristics, okay? Now, there are certain fundamental types, and if you remember your statistics from, your statistics from, I don't know, from your undergraduate capstone or capstones or something, you probably did a little bit of statistics here. They told you, right, in your stats course that typically one of the things that you do when you're conducting inferential statistics, for instance, I guess it's which statistical test to use. Usually when you're conducting inferential statistics, one of the things that you tend to pay particular attention to here is like the type of data that you're working with, is it? You see this here, interval, this is ordinal, this is categorical data and stuff, right? This tends to influence the type of test that you're going to perform, right? Is it a one sample t-test? Is it a binomial test? Is it chi-square, goodness of fit test and all those things, right? Is it a Fisher's exact test and all those things? It turns out that in data mining, these different types of data attributes are equally important, right? So there are these fundamental conventional types, right? As they relate to statistics, for instance, right? If you notice the different types of measurement scales, we can categorize them, into linguistic-centric data attributes or numeric attributes, right? And then we can further categorize these linguistic-centric attributes into, categorical or ordinal attributes, right? In fact, we can further kind of cluster categorical attributes into your nominal attributes and also dichotomous attributes, right? Where you're only dealing with like two types of values ideally. Anyways, the key thing here is that it turns out that each of these different data types that you tend to work with is associated with specific types of transformation techniques. Okay? When you are wanting, remember, we pre-process and we do these things here because we want to prepare, we're preparing the data here for the modeling phase, right? So the type of transformation and in fact the type of pre-processing techniques that you perform are in part dependent on the type of data attribute that you're working with or the characteristic of data. So if you're handling, categorical attributes, the way that you pre-process that data is going to be vastly different from when you're dealing with textual input, for instance, or even images, actually. Right? So these are fundamental types here, and I guess this kind of exemplifies the point I was trying to put across, to say when you're working on a data mining project, you will find yourself working with a broad spectrum of data, right? Numeric, if you look at the top left corner here, this data comprises of what? These countries here, right? It's a way of masking students, but these countries are essentially, these are categories, right? Algeria, Angola, Benin, Botswana, Burkina Faso is probably Zambia, United States and stuff. These are categories, right? These are nominal attributes, okay? So these are categorical attributes here. And then if you look at the values associated with quiz 2, 3, and class theory tests, these are numeric attributes. These are numbers, is it? Okay, the scales may be different, but these are numbers. You know, I mean, if you look at the image on the top right corner here, again, you notice that for these are shape files, I believe they are here. For provinces, this would typically be, if you notice here, provinces, Central, you know, Lusaka, Mchinga, Eastern and stuff. These are categorical attributes. Districts, again, categorical attributes, right? Chubombo, Chadiza, Sinda, you know, Chipata, Chipangali and stuff, you know. These are categorical attributes. And then if you look at the I think these are constituents IDs or something. These are numeric attributes, is it? Just numbers that uniquely identify the constituencies and words and stuff like that. But anyway, the key thing, and then at the bottom here you have like text or content. The key thing here is that you tend to find yourself working with data associated with different types of attributes. Okay? Now, I mean, in case we are wondering here, why is this all important here? Well, it turns out that input and output data involving, you know, AI or machine learning algorithms is supposed to be represented in a mathematical way. So in essence, the things that you provide to the models that you're building here and are modeling here as input are supposed to be represented in a specific type of way. The output from the model as well is supposed to be in a specific type of way. Typically, these are numbers. Okay, this is why we obsess about that. And typically, the representation. Let me just quickly see here. You know, we neither here nor there here. And typically, this representation would be more or less like in an attribute value pair, if you will. Right, and then you have different types of attribute types, like we earlier indicated here. Something else worth mentioning here is that this representation is typically dependent. It's typically dependent on. On the type of problem that you are addressing here, right? But generally, what you do is you can represent this model that you're implementing as a mathematical function, ideally, right? So you are interested in building a model that's going to act on whatever data you're working with, associated with different types of attributes, and then the output is going to be what you are looking for here. So the X and the Y are supposed to be represented in a mathematical way. So in essence, this XY here could be something similar to, well, the example I was giving, students at risk of failing, right? Y can be fail or not fail, something like that. And then the X here can represent things like gender, right? I guess age, I don't know, you know, cost, workload or something like that, and stuff, right? So a number of X's, right? So you can have it may not necessarily be X here. F of X can have a series of variables, ideally, right? Anyways, that's neither here nor there. Right, so the thing here, right? So you have this mathematical function that you use, but the thing here is it turns out that this input data, the f of x we're talking about here, would typically comprise of multiple instances or observations, the input data itself. All right? Remember record 1, record 2, record 3, or if you're analyzing comments, it's like you are here. I want to analyze these comments, these 37 comments, and there could be more actually, these 37 comments. These are what we're calling observations, is it? Or instances, right? Or records, rather, but they're called observations. right? When it comes to data mining, these are individual observations. So each observation is typically associated with a data attribute. And again, I'm simplifying this because in this particular example, you would only have, if I harvest as the comments, I would only be working with a data set with one attribute, is it? Think of an attribute as being a characteristic of data, or rather a column, right? If you look at the attributes relative to a spreadsheet or something. Attribute gender, attribute Python experience, attribute motivation, attribute age. I could say attribute student ID or something, but it wouldn't really be useful in any way because it's unique ideally. But anyways, so what we're saying is that the input data is typically composed of multiple instances. This is an instance, right? Instance, 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 or an observation, right? So an observation is like a record, and an observation ideally is described relative to its specific characteristics. For instance, the observation student 1 is a female with very low Python programming experience, and they seemingly are motivated by the fact that they just love computers and they're 18 years old, right? Instance or observation, ideally. So each observation is associated with data attributes or characteristics, okay? And it turns out that the attribute or the characteristic will facilitate the measurement of an observation. How old is student 1? Well, they're 18 years old. How much Python experience do they have? Very low Python experience. So I don't know what that is. What is their gender? They are female, right? So the attribute will help us measure the observation. Okay? And of course, the comprehensive set of all attributes in your data set will help you describe each instance or each observation or each record. Right? So the only way I can comprehensively describe each of these individual 5 students is by looking at these attributes associated to them. Is it? Yeah? They are different. This is what makes them different, ideally. Well, there are instances where maybe the attribute values may be the same. They may be shared, right, by a series of observations here. It's neither here nor there, but that's fine here. Now, attributes can either be categorical, of course there's more here, continuous. I guess I was going to throw in textual content and stuff, but text can be viewed as being categorical, I suppose, or something like that, right? Or if you convert them into numeric representations, it's say, well, I mean, these are like continuous or something, but no, not continuous, I guess, categorical. Images as well, if you represent them using the pixel representations here, the ones and zeros representing the RGB values, actually RGBA, right? The alpha value as well is quite important here. So if that is making sense. By the way, I may be talking to myself. Are you still there? Hello?
Yes, Doc, we are listening.
Okay. Yeah, I don't know. I thought maybe talking to myself here. Anyway, so what we're saying here is that our so-called data attributes can either be categorical or continuous, and your categorical attributes can be sub-categorized into. I mean, these are really usually qualitative, right, in nature for the most part. You're describing things and stuff, right? So they can be subcategorized into nominal attributes, ordinal attributes, and dichotomous attributes, right? Continuous attributes are typically quantitative. Now, it turns out, right, that when you're talking about these quote-unquote categorical attributes, specific categorical attributes, your nominal attributes essentially will help you describe, or you're referring to things that can be organized into 2 or more categories, but cannot be ordered. So there's no intrinsic order ideally. If this is making sense, right? For instance, Zambia, Malawi, Botswana, Zimbabwe, right? Please don't say Zambia, Malawi, Botswana, Zimbabwe. It's like, okay, I know you say, oh, but we can order them by their relative size, right? 750,000 square meters or something for Zambia. No, I mean, I could have maybe used something else here, I don't know. Maybe. But there's no intrinsic order ideally, right? For these things here. Or let's say laptop, cooker, pressing iron or something like that. Like there's no intrinsic order, there's just categories of things. And in this particular case, I have 3 categories, right? So it's a nominal attribute. You also have quote-unquote dichotomous attributes. I'm going to skip out my attributes for now. The idea behind your dichotomous attributes is here, they are actually nominal attributes, but they're exactly 2. Like gender, right? And I know, let's not have this conversation here. Let's say there's binary or something, or not binary, not that is here, but male in Zambia at least, it's male or female. Okay? 2, exactly 2. Right? So it's, in other words, your dichotomous attributes are just a form of nominal attributes, you know, if you will. And then you also have so-called ordinal attributes, right? Again, these are categories of 2 or more entities, 2 or more categories. However, you can order these things. They can be ordered in a certain way. Like at the University of Zambia, first year, second year, third year, fifth year, or fourth, I guess, I don't know, fourth year, right? These are categories, quite all right. We have 5 categories, but order matters, right? First is smaller than second or something like that. Order matters, ideally. You know, typically when you're working with data, ordinal attributes will be associated with things that are measured on a scale of sorts, discrete scale, right? Like on a scale of 1 to 5, how good are you at programming? Okay, wealth quantiles as well. I don't know if you've seen, I don't know if this is step survey here, wow. It's not there. I want to showcase a step survey or certain surveys that have been done here where they'll check for wealth quantiles in Zambia, right? Are you wealthy? Are you rich and stuff? Is it order matters, right? Okay? And this is important because it turns out, remember, we're having this discussion because we are saying that the type of processing that we perform and the transformations that we perform are dependent on the type of attribute that you are working with, ideally. Okay? If that makes sense here. Anyhow, and then you have you have so-called continuous attributes, ideally. Right? So continuous attributes can be, I don't know if people have worked with other weird types of other weird types of categorical attributes that you can think of here. I don't know if this is making sense here, or maybe we can go here. Categorical, ordinal something and stuff, and then you have numeric and all those things here. I don't know. Anyways, and then you have so-called continuous attributes, is it? And really, like we said here, categorical attributes are qualitative, right? They will help you measure, you're dealing with qualitative data. If you remember statistics, whereas continuous attributes enable you to deal with quantitative data ideally. So these attributes are quantitative. And you can actually subcategorize them into so-called interval attributes and ratio attributes, right? And really, what interval attributes do is they so they measure data continuously over a range of values. Okay, so the scales that you'll be dealing with are such that we know both the order and the exact differences between the values, right? If that makes sense. Whereas your ratio attributes, they have all the properties associated with interval attributes. However, you typically would not have what is called a true 0 point, right? So there's no significance in terms of the true 0 point, ideally. If that is making sense.
Mr. Perry, could you please explain what you meant by interval attributes and like the examples for interval attributes and ratio attributes?
Well, so maybe if I use an example, maybe this would help here, right? So your interval attribute here could be range of years, right? If you're dealing with years here, the difference between a given range of years, I guess it's like the year 2020 and the year 2000, for instance, would be an exact value, right? So the difference between 2020 and 2000, I don't know if my math here is going to be correct, but the difference between 2010 and 2020 is going to be the same as 2000 and 2010. It's going to be 10 years, if that makes sense, right?
Yeah.
But here's the thing about the 0 point here. If you say year 0, right, that's like an arbitrary point. It doesn't really, if you say year 0, it won't really, it doesn't have like some sort of significance really. Whereas when you're dealing with ratios, right, so it's interval, right? When you're dealing with ratios, for instance, if let's say you're measuring, I guess, Young distance or something like that, we know that 0 kilometers is going to represent something, a true 0 value, right? I don't know if this is making sense. Maybe we look at other examples. I think I have other examples up in front here, but yeah. I'm trying to think of another example here. I think I should have examples of where is that? Ratio attributes. No examples. Yeah, and this is a wrong example, by the way. I don't know why I haven't corrected it here. In the data set that we're using, I don't think we have specific examples of this. But I think temperature would probably be a classic example as well, right? I think. So think of time, right? Maybe time would be another example here. So if we say time of the day, is it? We have a range, right? I don't know if we have a range, is it? We have I guess we'd say midnight all the way up to, I don't know, some endpoint or something. But here's the thing, right? If you take into account things like 12 p.m. and 3 p.m., for instance, the difference between those times is going to remain consistent here. But the zeros, if we say time is 0000, that's just an arbitrary starting point, is it? There's no, we wouldn't say there's a significance with 0000. We know it's midnight, right? If that is making sense. However, right, when you're dealing with ratios, a difference of 0 has some meaning. I don't know if this is making sense here. I'll try and see if I can include more examples, right? But so they're all continuous attributes. They're dealing with numbers, and the only variation here is the distinction that exists in terms of the true 0 point ideally.
So, Mr. Piri,
Yeah.
Yeah, an example.
so could we say that, for example, for interval, the same thing where you said temperature, right? So in this case, temperature, when you say 0 degrees, the 0 has value, but then on the bottom one, on the ratio attribute, it does not have value. And in that case, maybe we can use something like sorry, I had an idea, but it's gone.
I was thinking of age.
Weight, maybe weight. When you say you weigh 0 kg, that has no, I don't think that would have value. You know, like how can you weigh 0 kg?
Yeah, I get that. So yeah, that would be. And by the way, I just realized something. I may have. So what we're talking about here makes logical sense here, but I may have. So this, and I do apologize. I have slightly. So for a ratio attribute here. There's supposed to be a true 0 point for ratio attributes, right? This issue here about 0 not having any significance here is tied to interval attributes. I do apologize. So just swap this, right? Ideally, this true 0 value here has significance in so ratio attributes. In ratio attributes, the 0 value has some meaning, right? Not that it has no meaning, it has some meaning. If I say yeah, it has some meaning. It has some meaning. I mix them up. I do apologize for that. But yeah, there was a question about age. There was a contribution about age. Sorry, I cut you short. I don't know who was talking about age there.
Hi, Doc. I think she was about to ask whether age would still qualify as an interval data type. And maybe just to add on the same question, I was thinking in terms of, you know how when you have age groups, let's say you have 18 to 25, 26 to another age, does that qualify as an interval or does it qualify as a ratio?
Yeah,
and then
I'm gonna start off with a question. Yeah, I'm gonna start off with age, right? So age clearly is is a ratio attribute here, right? You can classify that as a ratio attribute. You know, so we can say age 0 here there's meaning there, is it? You say age 0, you're just born there, right? I don't know if this is making sense here. So age is most definitely a ratio attribute. But what you're describing there, you are talking about 18 to, what were we talking about? Ages 18 to something?
Like let's say you say 18 to 25, 26 to another age group. Age, let's say.
Yeah, so this is not, these are not, yeah. These are discrete. These are categories. But special types of categories, is it? Ordinal. Right? So these don't fall under, these will not fall under continuous attributes. And I know this can be a bit misleading, right? Because you say, well, but I'm dealing with numbers here. There's a range of numbers. These are groupings, so these are categories. And typically these ranges here, they're discrete for one, and then they're finite, is it? So these are ordinal attributes. You're just grouping them. In fact, if you think about, here's the thing. If you think about first year, second year, third, fourth year here, another way of doing this is you could have easily represented them as first. Okay, maybe not, but this won't work. If I say 1 here, it's going to completely change things here. But there'll still be discrete values anyway, ordinal, right? Because it's odd. So these will not really be these won't be really continuous attributes. Really, they'll be ordinal attributes. If that makes sense. Anyways, I don't know if this is making sense. Okay, maybe.
What about velocity?
Ooh, velocity would be a ratio attribute.
It would, right?
Yes.
Velocity. Okay.
Yes, it's ratio.
Because 0 means the car is not in motion,
Yes.
so it has value.
Yep. Precisely. Now here's the thing, right? No pause here. We're having a discussion about data attributes, which is all fun and dandy, I guess. But it turns out that, again, the reason why we're having this discussion is, I'm going to double back here, the pre-processing operations and the transformation techniques that you apply to these different types of attributes may be different. The beauty is when you're dealing with continuous attributes, at the very least what you'll be doing is you'll be scaling things, right? That's all. Right? They're already numbers. One of the things that you do in terms of transformation is just you're scaling. And then perhaps when it comes to processing, when you're handling now values, you'd say you can impute the values by computing maybe the average score or something like that, if that is making sense. Arithmetic mean or something like that. Anyhow, hopefully this is all making sense here. And what I have here, by the way, are just examples from our data set, right? There was a bit of a mishap here. I was trying to find a way of linking these examples with, or linking this discussion with examples in the data set that we've adopted, right? The students at risk of failing data set. Technically speaking, this is ratio attribute ideally, right? Not interval here. So ignore this. I may have to replace this with something else, right? So these are just examples, right? 0 has meaning here, is it? Dichotomous attributes, exactly 2 categories, right? There's no order, right? If you look at, dichotomous attribute, and then you have your nominal attributes in terms of the minors. These are minor programs, right? Civic education, languages, mathematics, geography. There's no intrinsic order. There's no natural ordering of these things. We can't say civic education is greater than languages, for instance. No, right? They're all the same. In fact, they're associated with the same credit units or credit scores, ideally. And then you have your ordinal attributes as examples here, experience. But also, if you can double back here, this, where is that? The grades, yeah? A plus A, B plus B, C plus C, D plus D, and then F. There's an order, there's a natural order there, right? You don't want to fall into the trap of saying, well, if I have grades, if I have these grades here, A plus and A, I'll view these B plus, B, C plus C. I'll view these as I'll view these as nominal attributes. No, right? There's a natural order here. This is different from this is different from Lozi, Bemba, right? Chewa or something, Mambwe, right? Is it? There's no natural order for these languages that we have in Zambia, but there's a natural ordering here that exists. Anyways, these are all categories, but with different characteristics or traits, if you will. But just to kind of mention here that when you're dealing with these different types of data attributes, especially when it comes to data mining, you will find yourself dealing with very, very weird, very weird data types, right? You can view these as additional types, if you will. Okay. But it turns out that depending on the way that you are representing these different types of attributes, you can potentially classify them into either one of those different categories, right? So for instance, we could potentially view an image as, comprises of raw pixels, quite right, but we can potentially view it as a nominal attributes, for instance. All right? If we had it as a column in our data set, which represents, let's say, a profile picture of a user, for instance, right? Or as a racial attribute, is it? Yeah, so if we were to represent it as a profile picture, we could have things like image 1 or image 2 or something. There's no natural order here. In fact, you can't distinguish between image 1 and image 2 ideally, right? So it'd be like a nominal attribute category ideally. Whereas, if you try to represent or visualize the image as its constituent pixels, that's obviously going to be a racial attribute, is it? Ideally, because the 0 is important. I don't know if you remember your computer systems here, is it? Like they'll tell you that an image, come back to an image like this. An image like this essentially is made up of what? A series of pixels, right? And I'm trying to zoom in here so that I pixelate this. So I remind you of your computer systems. I don't know why this is not working here. But they told us that an image is made up of a series of pixels. This is like dots or something, right? These things here. And each dot, ideally, depending on the bit depth that you're working with, each dot is represented by a value, right? So if you're using, typically you don't use, you typically in a real setting you wouldn't really use just RGB. Really, there'll be an alpha value as well, right? But we know that these can actually be represented as a series of numbers, is it? Typically, these will be, depending on the bit depth here. So if it's a bit depth of 8, these numbers will range. There's supposed to be 256 of them. They'll range from 0 to 255, right? So that they're 260, right? Ideally. Anyway, so these could be racial attributes, right? Is what we are saying. So each individual pixel can be represented as a range of number, like these things here. These pixels, when you're pixelating this, yeah? I don't know if you guys remember this. This is an image, but an image that is represented in such a way that anyways, I don't know why this is my computer is misbehaving here. But we can view this image from the perspective of each individual pixels that make up these images. And you have the image with resolution 400, and I don't know if you remember this, colleagues. I don't know if you remember this here. Right? So if I check this, is it? They'll tell you that this image has a resolution of 1780 by 1408. What they're telling you here is that these dots, the pixels, there are 1780 of them lined up vertically here, right? Here. And then there will be 1480 lined up horizontally, like so. But each individual dot that you have in here, each individual dot can be represented by a value between 0 and 255. Don't know if you remember that here. Anyways, the point here is the reason why we would want to represent this as in images. 0 has significance, is it? I don't know what 0 is. You remember what 0 is? You remember your colors? It's tough like that, is it? White is white. What is if you have things in either extreme ends here? 0 is black, is it? And then 255 would be white. And then what you have in between, those different colors that you play around with. And in fact, you know, this is what we do when we're working with GIMP or something like that, right? I don't know if you've worked with tools like GIMP or something. They want to represent a color like this, and then you'd be playing around with these values here. Is it? Don't know. But anyways, we're not here to look at image processing here. Right? And then there's text, right? So if you think about it, right? It's like when you're working with text, a nice way of linking it to the things that we've discussed here, you could say you could view this as being categorical, right? It depends on how you're wanting to view the text here. You can view them as being categorical here because you are representing each of these things here as individual tokens, right? So we can get the chunk of text we're working with and then break it apart and view it from the perspective of the individual tokens or words making up that text. Okay, so these would be categories ideally. And then I guess when you do your transformation, so you come up with this representation here, clearly this would be continuous, right? So it turns out that if you look at text in its raw form, you could say that's categorical, but then when you apply certain transformation techniques here, like you're converting it to mathematical representation numbers, it becomes continuous, ideally. Okay. Hopefully this is making sense. The question you should be asking yourselves, well, but what about video? Well, video is made up of images, right? So that shouldn't be a problem here. Well, but what about sound? If you pause here, you realize, well, I mean, when sound, I mean, it's analog right now when I'm speaking, but as it's being transmitted on the other end to you here, it's converted in digital form here, right? And what are some of the key characteristics associated with sound when converted in digital form? The amplitude, for instance, which is a ratio, right? Attribute ideally. Anyhow, it's continuous, is it? So you notice here that all of these different types of data attributes that you tend to work with, it's like they can be tied to from a data mining perspective, right? Because you want to pause here when you're working on a data mining project, right? If you think about the things you're going to be working with here, it turns out that there's a restricted set of things you'll be working with, right? Numbers, be text, video, images, sound, right? Could be more things here, but is there something else I've left out here? I don't know if I've left out anything else here. Can you guys think about anything else that you, any data that we've left out here when you're working on a data mining project? Typically, it's numbers, you know, text. Yeah, numbers, text, right? I'll just put in categories or something if you want to appease you or something like that. Is it? So there's a restricted set of data types that you work with. You know, the context may be different, but the things that you do are essentially will involve you manipulating these different types of data types. And what we're saying here is that these different types of data types can actually be tied to these fundamentals here, these things. Is it? If that is making sense. But hopefully this is intuitive enough. Again, just to wrap it in terms of textual content here, we can represent the textual content using their individual terms. And I don't want to call them words here because, again, depending on the problem that you are working on, when you have a chunk of text like this, you may decide to say, I'm going to analyze I'm going to tackle this problem by analyzing these individual, they're called tokens for a reason, right? I'll use words or terms, right? The things that are separated by space when we write text, when you write it down. But it turns out that you can also decide to do this analysis relative to sentences, right? So let's say I'm going to extract things in my chunk of text, right, that are associated with sentences. So I'm going to view this token as being separate from the other token, which is up to here, right? So you're analyzing sentences. If you are working on some problem that would be doing very weird things, you're like, oh, I want to analyze the Bible, the Holy Bible, something, King James Version of the Holy Bible. Maybe your interest would be to analyze the verses. You know, so a point to put across here is that in as much as when we're having our discussion of, you know, text processing and stuff here, I'll be obsessing a lot on I'll be interchanging tokens and words, but a token is not necessarily going to be a term or a word, right? It can be a sentence. A token is essentially a unit of text, and that unit of text is contextual, ideally. But anyways, so textual content can easily be represented using, you know, interval terms, right? That comprise of the text, these things here. Yeah. By the way, if you are wondering, but how can you do this light on the dot? And I'm going to say, well, please split by. If you remember split function built in, split by dot. This is simplified though. I'm just assuming if I want to extract sentences, there's an easier way of, there are libraries that you can use to extract kind of like sentences, right? Like Spacy has features that allow you to extract sentences from chunk of text here. But what I've done here is I've said, well, I'm just going to use the dot operator here so that I separate all sentences. I'm assuming that sentences are separated by a dot. That may not be true, but for the most part, it makes logical sense. So sentence number 1, in fact, I can check. What is sentence number 1 here? This. Sentence number, I don't know. How many sentences do we have in record number 1? There are 14. Okay, so what about the last sentence? It's empty, right? And you know why it's empty? If we come here, there should be a double dot somewhere. I don't know why it's empty here. Weird here. I don't know why it's empty. What about the second sentence? Okay, third, you know, fourth or something, fifth, I don't know, and so forth and so forth. But why are we doing this? For var sent in here. I wonder if we can print this sent, right? All of the different sentences, one at a time, is it? Okay, that's neither here nor there, right? So now that we've done this, right, it's like there are a series of data types. So how exactly do we pre-process these different types of data types? Or another way of viewing this problem is how exactly do we clean up these different types of data types, right? What is pre-processing all about? Yeah. Well, simply put here, this whole process of data pre-processing or data cleaning involves you, no pun intended, but cleaning the data here. And it turns out that cleaning of the data involves a series of operations. Cleaning data may entail you removing duplicate entries. So you are performing what's called deduplication. Okay? Happens more often than people think, right? Because you must remember that this data that you're analyzing, text and images, video and sound and numbers, usually this would have been created by other human beings. And unfortunately, human beings make mistakes, a whole range of mistakes. Some mistakes that human beings may make is you're in a shop, right? You're doing data entry. Somebody has purchased an item and you record it twice or 3 times, right? So you deduplicate. Data cleaning or pre-processing may involve you deciding on how you are going to handle null values. The idea behind null values is simple. Remember, we mentioned that when you have a data set like this data set comprises of instances or observations. These observations have corresponding attributes, right, or characteristics, these things here. Now, typically, this data here will have to come from somewhere. There's a source, and a source is usually human beings. Some of the mistakes that people will make, human beings will make, is they will omit values. And you know where this is coming from. Usually, human beings will omit values if you foolishly create your software in such a case that you make certain fields optional. Right? You're a programmer and you've been told, make sure that you create a form for capturing students at this university or something. And one of the fields is gender. And instead of making the gender field mandatory with the red asterisk, what you do is you make it optional so that somebody forgets to indicate that this person is female and they just say submit or add the record, right? It will be a null value. It will be a missing value, ideally, right? So the idea behind preprocessing is you have got to figure out or come up with a plan on how you are going to deal with these missing values or null entries, null values. And it turns out, we'll talk about this here, but you typically would have to make a decision on whether you exclude the null entries or null values, right, from your analysis. It's like if there's any observation or instance that has null values, I don't want to include them in my analysis. I'm just going to exclude them. However, there are instances where you may not have the luxury of removing null entries. You have few data points or few observations. What you can do is you can replace the null values, right? It's called imputation, right? You come up with some value. And typically for some problems that I've worked with some of my students, like for instance, we're dealing with grades. I've been using this grades example here. Well, if there's a missing value, and this is the end of the semester, I'll add this as a 0 for this year, right? So in this particular case, I'm adding it as a 0. There are other unique instances where you might say, well, what I'm going to do is I'm just going to compute the average score. Let's say it's there's a missing grade. The student has test 1, test 2, quiz 1, but what is missing is quiz number 10 or something. And you say, well, this may not really be a 0. Looking at the performance of the student, I can, and of course, I mean, this has got to be tied to policy or something. I'm going to aggregate these. I'm going to look at all the scores that are available and then just get the average score and then impute it there instead of excluding it. Right? So typically you make a decision of doing this. And you see really from the notebook, the examples that we're going to be walking through here that Python Pandas actually provides us with really easy to use interfaces for handling null values and things of that nature, right? And things of that nature, or something final, vector unique, EF. Yeah, is there a question or something? I will look at this later on. Drop NAs, right? So you can drop them. Hi, is that a question? I don't know if it's a hand up or something.
Yes, I have a question.
Yes, please.
I want to find out what really influences the way you handle null values.
Great. So there's a couple of things here, right? Top on the list here could be the example I just gave here, where you have very few data points. Okay, and we haven't really got into a stage where we are having, kind of like a discussion centered around the importance of the size of the data set. But I may have mentioned this. I'm going to circle back to your question here, but there's I like using this myself. There's this thing here. It's called a scikit-learn. I'll call this a map or something. I don't know if you guys have come up with this, right? There's kind of like a map that you can use to to decide. I'm just going to open this. Can I? What is this now? So this, right? So if you're deciding on which sort of estimator you're going to use, you notice there's something important here, right after the start, right? You check. Is the data that you have, do you have more than 50 observations or samples? If not, go and get more data. If you can't get more data, you can't carve this out as a machine learning problem. Of course, there are tricky things that you can, interesting things that you can do, like you create synthetic data or something like that. But the data, right? If you're dealing with a very small data set, and maybe you're utilizing the more modern deep learning approaches that require massive amounts of data, right? You don't have the luxury of, because remember we are saying you have two options, is it? Handling, now values, remove, replace. So the question is, how do you decide on whether to remove or to replace? My first response is, for starters, the size of the data set, but also, in some instances, it's the importance associated with that attribute. I'm going to circle back here, right? If you have, let's say we're working with this sort of data set, right? We have 1, 2, 3, 4, okay, I'll include this, 5 attributes here. And then, let's say, this is our entire data set, and we realize that there's no age for these 2. Removing, right? In this particular case, I guess it is removing here, but removing can be in 2 parts here. You completely exclude or remove the observation of the instance, or you can exclude or remove this attribute. So you're saying, because we have a lot of now entries associated with age, our analysis is just going to be restricted to these attributes that have complete values or something. So there's that, right? It could be, but usually it's the size of the data set that you're dealing with. It's what typically would influence that, if that makes sense, really. But also, I think the context as well, right? There are some instances where replacing values is just not going to cut it for you. You know, maybe you can do some smart things here. Gender, right? It's like, I have no values for gender I only have 1 entry for gender. It's like, how are you going to replace gender, right? Like the type of attribute here. How are you going to infer that this should be male, this should be female or something? It's difficult, right? If it's a grade, it's relatively easy. You just say, I'm just going to get the average score or something. If you're dealing with money, right, in bank accounts or something, you say, well, I'm just going to look at the maybe the average amount in people's bank accounts or something like that, or I'll look at a history of this particular individual in the recent past, and then just look at the average, right, year-on-year average, and then I'll use that to replace it with the current year. If you don't have the bank account balance for the individual for the current year, for instance. You know, so in some instances it can be contextual, right? Depending on the type of attribute you're dealing with, it may not be possible for you to input the value, because how are you going to figure out what to input? If I'm making sense. Hello?
Yes, yeah.
Yeah, okay.
Wow.
Yeah. Yeah, any other thoughts? Okay. If not, I guess we can proceed here on this. You know, this issue of now entries. You find it, right? It's and I've dealt with a range of problems here. Usually it's human beings that are the root cause of these things here. Anyways, so that's that. Deduplication, you know, handling, you know, now values, and then dealing with outliers, right? Usually, right, there are things, outliers are observations that will veer off from the norm, right? And the nice thing about this is they've told you about the bell curve, is it? If, for instance, we were to graph results for these students here, there will always be outliers, right? If we were to graph this using a histogram, there will always be outliers, is it? If we were to draw a histogram, we will most likely come up with a situation where we have something like this, whether we like it or not. Something like this, right? A bell curve, they call it. Bell curve, something like this. Now, this bell curve really sometimes it can be that the performance is quite bad, but there are always these outliers. The outliers are entries that will be somewhere here on the edges, right? Freaks of nature, I guess. If you look at grades here, even if the test was really, really hard, right? There will always be people that will perform way, way better than the average. There will also be people that will actually be one of the worst performers, right? Maybe people have to get a 0, a 1 out of 100 or something like that. Right? Those are outliers, right? Things that are out of the norm, ideally. Yeah. So as part of pre-processing, you have got to also decide on how you're going to handle or how you're going to deal with outliers, ideally. Generally, what I've done myself is I'll just remove outliers. Just remove them. But it's always important to do your EDA, where you analyze the data to try and figure out the extent towards which you have these outliers. There are obviously sophisticated techniques that you can use here, but typically the best strategy is just to exclude them. You know, imagine you're building this tool that we're saying is supposed to tell us whether a student is going to fail or not, or something like that, right? I don't know, right? If there are people that are performing horribly wrong here, they're going to mess up your model. So what you do is you just remove them so that you end up with a much cleaner, right, model, right, that will give you a best fit ideally. Of course, the pros, the cons there would be that you're losing out on important information, perhaps. You can also do some rescaling, right? We'll talk about scaling here when we look at transformation ideally. Anyways, so that's that. It could be fancier techniques that you can use. But you notice here, right? Most of these things that we've been talking about here, like removing duplicate entries, removing null values, or dealing with null values, dealing with outliers, these things will be applied irrespective of the type of data that you're working with. Whether it's text or content, video, images, or sound. If they're duplicates, you've got to handle them. If they're outliers, you get to come up with a strategy on how to deal with them. Okay? If they're missing entries, you've got to come up with a decision whether to replace them or to remove them completely, right? But it turns out when we're dealing with certain types of data like text, there are additional operations that you're going to perform. And there's a reason why we typically obsess a lot about text, right? Maybe things have changed here, but if you just think here about the broad spectrum of data that you deal with, what you begin to notice is that a significant chunk of data you deal with on a day-to-day basis here is text, actually, right? Social media, right? Textual content, blog post, WhatsApp groups and stuff. Of course, the world is changing now. These micro blogging sites have sort of like changed the game here, right? I'm talking about Instagram, in fact, YouTube Shorts and stuff. So increasingly, I guess one would argue that there's increasingly a lot of video content that is being generated, right? And I guess if you look at WhatsApp as well, increasingly more and more people are gravitating more towards, what do you call this? Voice notes, right? I hate those things. It's too much work. I don't know, maybe I'm old school or something. But if you think about it, text is still, right? Text is still king here. In fact, if you think about the different types of use cases here, quite a lot of it, the corporate world, for instance, it's going to involve you dealing with text at some point, right? If you work for a telecommunications company, for instance, by the way, even if you're working with sound, right? At some point, you're going to have to transcribe that sound, is it? No, we're analyzing call center queries that are coming through to the call center to try and figure out how good we are at attending to customer queries. There are people that are insulting you left, center, and right here. What you do is you get the audio, right? And you're going to have to convert it to text, is it? You don't, that's how you typically would analyze your audio, right? You don't just analyze it directly. I mean, there's certain use cases where you can do some fancy things here. But typically you transcribe, right? You transcribe. I don't know if I've told you what I typically do myself. For most of the stuff here, most of the classes I teach, I record them, right? I also record, there's a bit of data mining, I guess. Maybe I should include this as an example. I'm also recording this using TLDV here, like this, right? Now, the thing here is, and I don't know why I do this here, but I dump these on my YouTube channel, right? All the courses that I teach here. Now, one of the things that I've noticed is that undergraduate students especially, and I guess you as well, which I understand perfectly, it's difficult to consume a 3-hour long video, right? Or I guess one would say a 45-minute long or 1 hour long lecture session, right? So if you've used YouTube, for instance, you notice that YouTube has introduced chapters, right? I don't know if you've heard about chapters here. So the idea behind chapters is that YouTube has actually an algorithm that kind of makes it possible for you to, the idea of creating chapters can be automated. I don't know why this is taking a while to load here. Maybe I should, nope, sorry. I don't know why it's taking a while to load here, but okay, there we go. So YouTube has a way of creating these things called chapters. And I don't know, maybe the view on your phone may be slightly different, but you know how when you're viewing a video like this, you can view the chapters, right? So these are segments of the video itself, properly curated. So sometimes, if you've configured a YouTube channel in a certain type of way, YouTube has like an algorithm that will automatically create these chapters for you. What I do myself is I create these chapters myself, right? Manually. In the past, what I would do actually is, because it was a way of trying to encourage, especially first years, for instance, to make sure that they're on top of things here. So I'll create chapters so that it's a lot easier for them to go to a specific portion of the video where there's important things that are being discussed. But what I do now, right, is, and my workflow here may be a bit retarded or something, but I'm going to say it nonetheless here. So I have a video, right, recording. Like right now, there's this thing that is being recorded here. There's this file here, right? OBS is like in a loop here. It's recording my screen, my entire screen, right? And my audio and stuff. It's neither here nor there. So what I'll do is, because this is a video file, right? If I play this back here at the beginning, I don't know if I'll be able to play it back here, but it's maybe not here. Yeah, so it's the beginning of class or something.
From data selection.
But so I'm creating this. So what I do is, I will use FFmpeg, right? So I'll use, I guess it's a bit of data mining, maybe not. But I'll use FFmpeg, right? I don't know if you use FFmpeg, people. Quite useful, actually, also. I'll use FFmpeg to convert this to MP3, right? I think it's a nice way of pausing for a little while here. We'll go back to where we're supposed to go to. But because it's an MP4 file, I'll convert this to MP3, right? Because I'm interested in the audio. When I convert this to MP3, what I do is I use a speech-to-text model, okay? There are quite a number of them. I haven't really updated myself to try and figure out which is better. In fact, some of these LLMs are multimodal, right? So you can, use an LLM foundation models to do these things. But what I do is I use Whisper, okay? So I use Open Whisper, it's called. And literally, I have this in here. I use Open Whisper. I don't know if people have used Open Whisper before. very, very, there's a GitHub repository. If you ever find yourself working on a problem associated with a speech to text kind of problem, right, where you're playing around with speech and you want to convert it to text or something, Whisper is the way to go. And by the way, there's a lot of applications, right, within the Zambian context, because most of these models will not understand Chichewa, Silozi, or Ichtonga or something like that, right? So there's Whisper here. This is how popular it is here, 2.3K stars here. But so what I do here, right, is I will get the MP3 file. Where are you? And then I'll use Open Whisper, right, to transcribe it. I transcribe it to text. I get a transcript. And the way Open Whisper works, by the way, it's quite interesting also. There's I don't know if I have an Open Whisper file. Not quite. I wanted to showcase an example of an Open Whisper file or something, but maybe I can at a stage or something like that. I can showcase something else here. Maybe it would be nice to show. So I'm describing a pipeline, by the way, right? So I have video recording, right? Converted to MP3. This is MP4, could be MKV, doesn't matter. Troska. And then from here, I use Whisper to convert this to text. I transcribe, ideally. Whisper does the transcription. And then I use that transcription. I want to showcase this to you. I don't know if I have. I think I do. Maybe not. Sometimes I don't. Maybe it's in admin or something. I wanted to, because it ties into some of the things that we have actually done or something before. And I should do a test and figure out. But I'm going to showcase also, because I do this for minutes as well. It's quite useful. Don't know if I'll be able to find. There we go. So what Open Whisper does, right, is going to generate these files here, right? There's a JSON file. I can probably just download this or something. There's a tab separated file. I've never really found a use case. A use case for a tab separated file versus a tab separated file for this particular thing. I'll open it up so that you see here. And some of these file formats, here a bit weird here, but you know how you have a video and then you have like closed captions or something, so that's how you'd use the subrips here, like SRT, for instance. This is open, and then there's a plain text file. So what I do is I will get. I'm gonna go back here so I showcase this. Right, I will. And the transcript from Open Whisper is something akin to this. Right. So this is one of them. This is an SRT here. You can actually use this to burn your captions within a video, right? I don't know if you've come across videos that have embedded captions. You don't have the option to switch them off or something. It's different from YouTube, is it? YouTube has this nice nifty feature. I don't know where this is coming from here, but YouTube has this nifty feature where you can switch on captions, right? CC, where are you? I don't know, closed captions here, so that you actually see these things here, right? Like so. So if you dump it on YouTube and stuff. But in some instances, there are videos where you have like these things embedded in the video itself, so you don't have the option to exclude it. You can use this SRT file to bend them there. And you can do some really interesting things as well. Like I think I've done this on my vlog channel also, where I've bent the caption somehow. But so what I do then is I get this, right, and then I generate the chapters here are not automatically generated. This is me generating these chapters. And really, as a way of experimenting, I've been doing this to experiment with these things here, right? With these things here, like this, right? We were doing a what do you call this? When we were at the ICTAS Tech conference that was there, we I was with Professor Kaleji from CBU, and I was doing a training on local large language models, local LLMs and stuff, and so we did some pretty nice things. We created an LLM and customized it for ZRA and stuff, right? Simple stuff, really. It's not complex. But what I'll do is I'll throw these at a local LLM, right, and just use the LLM to say, can you use this transcript, right, to generate what I want or something like that. It's quite useful, I guess. Works quite fine, surprisingly well. Prior to LLMs, I would have said, and this actually works, it'd be nice as an exercise, I would have said, I'm going to get all of these, right, transcripts here, right, for these time frames, and then try and see if I can come up with topics, right? This is topic modeling 101 here. I identify topics associated with this lecture, and then I try and check this text here, is it associated with that topic? If it is, then I cluster them together, and then I can come up with this, right? But the key thing here is I have like something like, I know it's a thing here, but I can't even remember why I was talking about, I was using this as an example here, but it's to do with text, is it? Yeah, I remember now. I was trying to say that everything, if you look at text here, right, most of what we deal with is text, because even when you're dealing with video, at some point you'll be dealing with text, right, captions. When you're dealing with audio, well, we want to analyze what is being, you remember what I told you, what we discussed early on, I don't know if you guys remember, colleagues, when we were looking at the very first lecture, I told you that there have been weird things that people have done, people in position of power. I guess we can talk about them now because they are no longer in positions of power, is it? We can rat them out and tell them that the thinking there is fundamentally flawed. There's no thinking. I guess maybe there's a bit of thinking here, but there's no thinking really. Remember this? Government, this was what, in 2019, government wants help with monitoring content from radio and TV stations in Zambia. I was like, how the hell are you going to do this? But again, I guess you can crowdsource, right? You tell people and they do this actually, this IBA or something, they'll say, they normally advertise on radio. If you hear something to do with hate speech, report to this number or something. So you report the radio, and I don't know how they're going to go back to the radio and say, give us what you are, give us a recording of what was presented on radio on this particular day. But it turns out, right, you can easily create a system to monitor this. This is like real time, so it's be computationally intensive, and all you're doing really is, in real time, you're just transcribing. It's difficult to analyze audio. So what I'm trying to say here is, you have got to, if you're interested in monitoring content on the radio, I don't know if they did this, probably didn't. They were talking about the Chinese here, I think I remember. I was like, why? What is going on here, right? These are simple problems that our students can do. But if you're looking at doing this sort of monitoring here, you would have to figure out a fancy way of converting the audio to text. And then what you're analyzing is actually the text, if this makes sense. And I've been wanting to do this, especially for the important places, right, where people are recorded in public, like Parliament. I don't know if people watch Parliament TV. You know, you want to see what is my area member of Parliament talking about here. Are they actually putting my needs, right, first? Or are they just there keeping quiet? But that's okay also. So, but what I'm trying to say here is that, in essence, audio is just text. So my pipeline works as the final output, and I know it's trivial. This is what comes out. And so if there's a student will say, oh, in this particular lecture, quite all right, we're discussing fundamentals of visual computing, but the part that I didn't really understand was when Lighton was talking about normalized device coordinates. So instead of watching the entire video and trying to waste 45 minutes, you're just going to watch this segment here between the 11th minute and the 18th minute, and then you're done. I didn't understand how the calculation of image resolution in pixels was done, and then you come here, apparently. Anyways, but also, I guess something else I can do is try and see if I can create shorts from here. Not that my channel is really, but these are done for experimentation purposes, right? So if I'm creating shorts here, I can easily splice out, right, the segment that discusses an important concept or something like that. That was a nice way to break. I don't know if any thoughts about. I don't know if I thought I had a question or something, a hand up. Maybe not. All right. So the question then is.
Sorry, Doc.
Yes.
Sorry, Doc. Just a quick one. Is OpenWhisper open source?
It is
or
open source.
Is it a paid?
It is open source. Okay. Quite trivial to use. So I think I was on the GitHub repository here. Freely open source here, right? Freely open source. It's right there. And you can experiment. I do encourage you to experiment with, they have different models, right? Of course, there's different models. These different models will require different compute resources. Okay? If that makes sense here. But it's freely available. And what I do myself, because this is computationally intensive, what I do is, it's the reason why I have this Google Colab, right? I do this using Google Colab, right? So, in fact, here's the thing, I must say this. I use this quite a lot, actually. Meetings, I coordinate postgraduate activities, and we were having a series of exams. Create what was discussed and stuff, right? It makes life a lot easier here. Anyway, so I'll typically use, I believe I mostly use, let me just go to the part where I'm specifying the model, the type of model that I'm using. Somewhere here, it should be there. Here, right? The type of model. So you have the option here. They'll typically require different compute resources, but when I'm using Google Colab, it works surprisingly well. I mean, it takes a little bit of time because I mostly use, the free tier of Google Colab. I don't, if you remember our discussion of runtimes, is it, where you can change the type here. I don't spend additional money, right, to gain access to these things here, right? I would have to purchase, I would have to pay extra money here. But if I was wanting to work on something large scale, let's say I just want to monitor Millennium radio station or Radio Chengel or something, I guess the office of the president has approached you or something. You say, we're going to pay money here and use these compute resources that come at a price. And you'll be able to do most of these things in fraction of a second, not really a fraction of a second, but instead of you doing it in let's say, I don't know if it's 20 minutes or something, you do it in a relatively shorter period of time. Because remember, you would be doing this in real time, is it? If that makes sense. But I know it would be tricky here, right? 24/7 radio and TV, this, by Miss Celia here, right? Apparently. I think there were, I don't know if you heard about this, it was a long time ago in 2019, but we can look it up and try. They were talking government monitoring content from radio, and I'll just go to lusakatimes.com or something. It's here.
Dr. P, I think I heard something like this. There's what they call what is it? Stanchart Bank.
Uh-huh.
They have what they call youth to work, and then youth to work recruits firms. So there is a firm that actually is people are paying for the service just to hear how many times their advert is being advertised on radio or something.
Yeah, so
Uh,
probably, thanks for, thanks John for that. So probably what the firm has done behind the scenes here is they probably implemented something similar to this. And I'm glad you're giving me, you're actually sharing what people are doing, right? You know, when you're doing these advanced degrees, right? You want to be, oh, it's not me to tell you to be smart here, but I'm sure you figured things out here. You know that these emerging technologies a nice way to spin off companies, right? I don't know if you've thought about this here. It's a nice way to spin off these companies, and the broad spectrum of applications. You know, especially for you guys that are doing AI, because you're doing more specialized things like NLP next term. You know, the other fancy things that you're going to be doing, and really there's so much that can be done in Zambia currently, where very few people are actually leveraging AI. And I know this because I've been interacting with people, training actually. I don't know how many times we've trained people from ZRA, right? Since I joined UNZAS, beginning 2019, a group from ZRA has come, training AI, right? When I'm attending these workshops, like I was at ICTAS, right? This is like a grouping of people that are working from these major organizations. Do a quick poll here. Is there anybody from an organization that has set up an LLM? Nobody. You know, but I guess it's like emerging technologies or something like that. But I don't know. All right. Anyways, so that was a nice way of pausing for a little while so we can continue. So there's a series of text-specific pre-processing techniques that you typically perform, right? I'm going to go through these one at a time here, okay? So that we understand, right? Typically restrict our kind of like discussion to these things here, like case forwarding, stemming, you know, stop with removal, removal of punctuations, deduplication, which we've already discussed, and null values and tokenization. Yeah, so we'll stick to these things, but there could be more, and not there could be, there are actually more operations that you can perform here. So the idea behind text forwarding is simple, right? Remember that when you're dealing with text, casing is important, is it? Right? So a word like RDBMS in all uppercase is going to be considered to be different from one that is RDBMS in all lowercase. And so the idea behind case forwarding is you want to use a consistent case. Okay? You're changing all of the, I guess, the tokens or the document terms or the textual content to a standardized case. Now, you remember from your programming 101 here that there are different types of casing. In fact, it's not programming. We've been learning how to write here for a very long time, is it? We can represent text in terms of casing in so many different ways, is it? Uppercase, lowercase, title case. I don't know if it's title case, sentence case, casing. Even camel casing, right? I don't know why you would do this here, but in Java, yes, I don't know. Title casing as well, right? So the idea behind normalizing or using a standardized case is you choose which casing you want to use, and typically the options that are there is either lowercase or uppercase, right? It would be unwise of you to say I'm going to use title casing or sentence casing or, God forbid here, camel casing, right? So you either choose either one of the two. So you don't really care if the text that you're working with, like this example here, some of the words are in title case, some of them are in lowercase. When you standardize the casing, everything is going to be normalized. That's the idea behind case forwarding, right? You are using a standardized case. Now, if you remember from our discussion of Python, if you remember from our discussion of Python, we made mention of the fact that the what do you call this? The string is here. Yes. The string class has a series of methods, right? Is it? If I have a thing here like CSC 741, I have access to a string class. It's a string type, right? Type is string, str. Right? And if we use the excuse me, the dir, you find that you have access to methods, right, associated with string class ideally. You can take advantage of these things, right, to case forward, ideally. Okay. So remember I mentioned that you are using either lowercase or uppercase typically. So it's as easy as just doing something like this. I want to case forward it so that it's all lowercase. Or it's upper, right? So that it's all uppercase or something. I would stick to lowercase if I were you. It's the standard. It's what most people do actually, if that makes sense. Okay, so that's the thing that we're doing, right? And maybe just to mention here that it wouldn't really be as simple as this when you're working with a data frame, okay? You'd have to do some fancy things because remember in a data frame, I don't know if you remember this, but I'm going to remind you here. When you're dealing with data frame, right? Playground, I think it is, where we have, goodness gracious me. I'm just going to convert this. I'm going to convert this to CSV. Maybe it'll be a lot easier. I'm surprised at this thing. I want to delimit this not with a comma but with a pipe symbol. It's usually safer. I don't care. So I have this, right? I don't know how much of this you remember. I just want to ensure that we have. So we have something like import pandas as PD. I just want to demonstrate something here to say. I'm going to just say records is equal to pd.read CSV. If you remember these things, read CSV. What are we reading? We are reading playground / this, and then the sep is going to be equal to a pipe symbol like so. So that I have these records, right? These are the columns. If you remember this, the shape, right? So I have 1,803 records with 8 columns, which is fine. But if I check the columns, what I'm interested in is maybe text or content is going to be what? Weird here that there's no description, but I'll get the title. Okay. So the idea here is just make the title like this. The idea here is if I wanted to work with this text, right? These 1,832 records, and I want to case forward these things. You see, this thing is this is a series, is it? It's a pandas series, right? Now, for you to change this, one of the things you'd be doing here is they say, well, I want to create a new field called title law or something. I don't know, call this title law. Now, the thing here is that if you are trying to case forward this data set that has 1,832 observations, it's like for each of these individual observations, you case forward, you change to lower. Well, guess what? Surprise, surprise, it's not as easy as you can't say, I'm going to come to here and just say lower, right? I mean, I guess you can or something like that. But typically what you do is you create some sort of utility function, ideally. I mean, there are things that you can do here, right? And then you can change these things, I guess. but I don't want to kind of think here. You can change these things, right? So, but the idea is you create a function here, it's a to law or something like that, and you say, oh, I want this to take in a string input or something, and then all I'm doing is I want to return var input dot law or something like that, right? And then what you then do is you could say I want to create this to law here, and what I'm going to then do is I'm going to get the record entry, which is the current title, like so, and then I'm just going to apply this new function, apply this to fr to law or something, right? By the way, the reason why this is the reason why this is not working, I believe I know why, is because observe, some of these are probably they're probably now entries. They're probably now entries, and the best way to do this is, if you remember our discussion, is you can just sample them out, say 10 or something. Some of these are now entries. So what I can do here is I can just say, I know they are now entries here. In fact, I can just do is NA or something, right? So what I can do is I can do this, is it? I can say I want to get all records where this is now, something like that, and you can figure out what this is. Anyways, so what I can do though is I can say I want to fill all NAs. I'm just going to have it in here. I'm just going to replace all now entries with this, so that error is not there. So if I go back to here, right, this will work now. So what I've done really is I have case forwarded all of my, but of course now what has happened is I've created a separate field, this to lower. You can do an in place, but I like modifying my data frame in such a way that I recursively create more and more columns, right? And then I start deleting things if I have to, or I just splice it. I specify what I'm interested in at any given point in time in my pipeline, ideally. But guess what? Now what I've done is I have case forwarded with this. I've case forwarded the title here using this field. So all of them now are case forwarded. In fact, what I can do here is I can say I can it won't work really, but maybe it will work though. But I can what did they tell us? I can get these, right? This won't work here because I need to specify this. If I wanted to compare these, you notice here that this record here has been case forwarded to this ideally. Anyway, the point I was trying to put across here is, in as much as we're simplifying things here when we're case forwarding and when we are doing these other fancy things here like stemming or something, in an ideal case, in a real world setting, what you're doing is you're performing these operations on your data frame, on your data set. You can do this recursively if you want. You can do this a brute force way, right? I mean, you know about programming, is it? If you want, you can say, well, I'm going to loop through this thing one at a time and then get the string, convert it, and then add it back to the data frame. But I don't know why we want to do this. A utility function is usually better. So that's case forwarding. You're just using a standard casing, ideally. Okay, and then there's stemming. So the idea behind stemming is simple. You're essentially changing, I guess, your terms. Think of them as the words or something. There could be sentences here into the canonical versions, ideally, right? And the reason is simple. I think I already made mention here that because our motivation here is the vector that you end up working with, this is usually very very dense, is it? Is it sparse? And so what you want to do is you want to reduce it to its smallest possible form without compromising the effectiveness of whatever it is you're doing, right? So you do these fancy things here, like you stem, for instance. Okay? You're reducing waste to their root form, ideally. Okay? So go here. Anyway, so you're reducing them to their kind of like a root form. And examples here, I think I already, I don't know if I can use Zambia, Zambians, or something like that, right? Yeah, so, and really, if you look at, the interesting thing about stemming, by the way, is that if you look at the stemming algorithms and how exactly they're implemented, right, all you are doing is you are just chopping off the suffixes. It's like, oh, sorry about that. It's like, if we come here, right, computer, computers, computing, compute. I mean, these are the same things here, right? Ideally. I mean, they kind of like, they may mean the same things, right? To a machine, this could be, to you and me, right? When we are reading these as part of text, it's kind of like tricky for us to make sense out of what is happening here without without having a bit of context. Like you're looking at the words that surround the word computer and computers or something, right? But ideally, it's the same thing. So what this stemming does, really, you're reducing its root form, so you're chopping off the suffixes. That's the way these things work. And at your own time, I do encourage you to, I don't know if I have NLTK here. I think I did install this. I'll be surprised if I didn't. I did because I showcased this, right? So I can import NLTK, and then I'll say from NLTK dot. You remember this, right? I can import. In fact, look at this. NLTK dot stem. Right? These are the different stemming algorithms that you have access to. These are ways in which you can cleverly chop off the suffixes, ideally. But what you begin to notice, the examples I have in the notebook actually uses the Porter stemmer. Now, this is actually a stemming algorithm that a lot of other people would typically use. My advice to you, if you're doing this in a real-world setting, is you want to experimentally determine which one is better, right? By conducting an experiment. If I use Porter stemmer, or if I use Snowball stemmer or something, right? Or the Lancaster stemmer, which one results in better performance or something like that. So the idea behind this, observe, right? So it's an import NLTK, and then from NLTK.stem import, I'm going to get the Porter stem or something. Okay, and then what you do really is you can just say I'm going to create an instance of the Porter stemmer, right? Porter stemmer, like so, easy to use. Type, right? There we go, Porter stemmer. And then what I'm then going to use is what I'm then going to do is I'm going to use this instance of the Porter stemmer and stem. What am I going to stem? A word, computer. Right? What do I want to stem? Computers. What do I want to stem? Computing. Right? If this is making sense, I don't know if there's anything else. Computing, computers, computer. Yeah, computer. Yeah. You understand what's going on here? So the way this works, if you notice, you're just chopping off the suffixes here. Right? And, you know, some of these things are interesting to read up and just try and understand how these algorithms kind of work, I guess. But also, I guess for the purposes of CSC 5741, just viewing these things as a black box is fine, you know. We're not interested, we're not here to learn exactly how these things are implemented. But an interesting thing to do here is you could do the same thing here and say, well, you know what I want to do? I want NLTK. What I want to do here is I want to see the variation with the Lancaster stemmer. So what I'm going to do is I'm going to do the stemmer I'll call this Lancaster, is going to be equal to, I should have imported it as well, right? I'm going to come here, import. You know what, guys? I'm going to import everything. Why not? And then I'll come back here, and then I'll say Lancaster stemma, like so, all right? And then what I can do is I can use the Lancaster stemma to do the same thing, right? What do I want to stem? Computer, okay, dot stem. Sorry about that. Computers, computing, this is one and the same thing. So the behavior is typically different. I don't know about children or something, I don't know. The behavior may be different for these different algorithms, right? Children. Yeah, I don't know what that is here. But what if we stem using Porter, right? The Porter stemma, which is this. You see this? So here's the thing. If you notice, there's already a difference. I'm just randomly checking this, right? When I'm using the Lancaster stemma, right? Children, yeah. It's kind of like stemming children in such a way that I have this, is it? It's removing the EN. But when I use the Porter stemma, this is the Porter stemma, right? It gives me children. So the behavior may be different. I don't know about Zambia. Zambian. Oh, but Zambians for Porter stemma. Okay, that's okay. Zambians is the same. But what about guys? What about the Lancaster stemma? This is wow. You see what this is doing? It's about Zambia. Oh, the Lancaster stemma is actually even better than the Porter stemma. If you notice, Porter stemma does not distinguish between. I don't know if you're checking here. It does not distinguish between. This is my Porter. I'm going to change this, right? This stemma here. This is a Porter stemma, right? Type. Right? It's a Porter stemma. I can change this also if you want. It'll be easier here so that it's. I'm just going to var stemma. This is a Porter. Right? So if you check, if we try to stem, because we know that you and I, all of us here, have agreed here that Zambia, Zambians, right? Zambians. These are pretty much, it should be like the same. They should be reduced to their root form, the same root form, right? Yeah. So if we say Porter, and we try and check here. By the way, guys, we discussed this also. I don't know if you, maybe not, but we can do list comprehensions, is it? I'm going to create this, right? var Zambia, right? Is equal to this. Zambia as a way of testing. Instead of manual, Zambians, or something, right? And then what I can do is I can use this comprehension here, and then in Zambia, I'm just going to loop here. I don't know how this is done here. So the var stem Porter, right? Dot stem. What do I want to stem here? I'm going to say var word or something. Token is better. Token, right? For var token in here. Do this. So for this is Porter stemma, right? Horrible. It's telling us that when we try and stem these words here, we're just returning Zambia, Zambian. It has only attempted to stem Zambian. It's identifying Zambian and Zambians as being the same. But guess what? If we do this using the Lancaster stemma, right? I guess like that, beautiful stuff. At least it's managed to stem the 3, right? If this is making sense. I don't know. But these things, it's always nice to, TK. I'm curious now. Let's check the other stemmas here. I've never used Snowball stemma here. I have no idea, no clue what this is here. So we can do the same thing here, right? We'll create an instance here, var stemma Snowball is equal to this, is it? Boom. Ooh, it appears it's expecting I don't know how this works here, but the way it works, I have no idea how it works here. But it's expecting a parameter, language, argument, language. What the hell is it? I don't know English. You know, when all else fails here, I think we can do a help, right, on var stemma snowball. Okay, we can't, but we can do a help on excuse me, NLT. Come on, we can do a help on snowball like this. What does it take in here? Yeah, but ENG doesn't work. It has to be English or something. English, yes. Beautiful. So we can do the same thing here, right? We can check how does this snowball thing here work in comparison to these others. So this is snowball. This is Porter. And this is horrible stuff here. This is Lancaster. I would gravitate. I've changed now. This is Lancaster stemma. I've changed. I think Lancaster stemma appears to be better. But you know, how about code or something? The other way of doing is programming, or something like that. Programming, programmer. I guess I'll even throw in a programs or something, right? Can we check how this works? Don't know. We'll start with Lancaster stemma, var code. Ah, okay. This is beautiful, right? It stemmed everything into, so program, programming, programmer, programs are all stemmed to program with Lancaster stemma. Well, how about Porter? Porter. Whew, horrible. Not. I don't like. You know. I don't know why I always use Porter, because Porter kind of like is what you find in most of the these tutorials that you find online. But clearly here, right? If you look at the Lancaster stemma, it's far much better than the Porter stemma. Right? Porter stemma for program, it's still program. For programming, it's program. For programmer, it's program with two ends, right? You know, horrible stuff here. I don't know. And then we can try out the snowball thing here. Anyways, so the key thing here is you have a sense of how you're stemming. Now again, similar to this, the way that you would actually be stemming these, remember, right? It's like you're doing this recursively, by the way, right? You case forward and then you stem or something like that, right? So remember how we have these records here where we have this new field. Well, one of the things that you do after case forward is you have to stem this, right? So it's like, how do we stem? Well, what we can do is we can say we're going to create another new thing here, another new, I guess, var record. We're going to call this title lower. I'll call this stem anyway. Stem, right? So I would need to do the same thing. I'm applying them to all of these things. I've got to stem. So how do I stem? Well, I've got to stem by first of all importing the stemma using NLTK and stuff, or you can choose your own NLP library that you want here. So I'll go through the same process and then create an instance of, let's say, Lancaster stemma, which I've already created, right? I've already created a stemma Lancaster here, right? So I can do a stem here. But how do I stem? Well, what I can do is I can say I can create a function as well. I'll call this stemma something. And what this function is going to do is it's going to take in an input string or something. And then what I'm going to do, I have the inputs already. I'm just going to return. I'm going to return var underbar stemma Lancaster.stem. I want to stem this var input, like so. Input, done. And then what I'll then do is I come back to this. I want to create a new thing here, but the way I'm creating this is I'm going to get the title lower, like so, and then I'm going to recursively apply the function to all of my 1837 or something using the function stemma, like this. So I've stemmed. And if I check my records also, columns, I have this new pandas, right? This new column here. And if I check this now, var record or something, and I try to check this. These have been stemmed. I don't know if you can check if they've been stemmed here. Canceling. It should have been stemmed here. Stem. There has to be a way of check. Ooh, this is complex. Sorry, I do apologize here. Wow, this is slightly tricky because sorry about that. Because observe, you know, this is beautiful. This, we don't stem an entire string. What we stem is the terms in the string. Okay, so what we'll have to do is we'll have to do this in a very smart way here. Df stem or something, and then I'll just say I'm going to say string here, or input still. But what we're doing here is we're saying we're going to get this the entire chunk of text. But you see, this entire chunk of text, and it's going to be tricky here. We're going to have to loop through this. This entire chunk of text here comprises of this. We have to split it somehow. Split, right? On space. And then what we're actually doing is we are then going to have to, I think we can do this. I suspect we can do this usually when we don't have to think about this here. But we can split this. In fact, we can do list comprehension like we did before. And then we can say var stem, we're using Lancaster, right? Dot stem. And then what I'm going to do this here is we're stemming the what? The var token or something. And then it's a for var token or something like that. In here, once we split them, you're going to return this as well. And then what we're going to do is we are going to have to, let's see here, because I want to return this string here, Zambia Republic or something. Var I is equal to this. Let me say var I. Can we join here? This is the part where join list into string or something. There's a join function, string.join. Okay. So we can loop and do a string.join or something like that. Beautiful. Okay. So we just get the thing here. Yeah. So we come here, we say we're going to get, we are joining them by an empty space again. We get the terms, we join them, dot join. Beautiful. There we go. We're running out of time here. We have to use it. So what I'm doing here is I'm going to say, I'm going to return this, right? This return this dot join. This is weird here. This is supposed to work. I don't know why it's perhaps you forgot a comma. Okay, so what I'm going to do is I'm going to get this again. I think there should be something wrong. We are in a hurry, is it? I guess we're in a hurry here. Okay, I think I know where it is. The input is not being used here. So we need to get for var token. Oh no, but it's there as well. Input is there. I'm gonna go back here. Sorry about that. And var record or something. Just try and see if I can get title law or something. I'll use this as a way to test. Var test is equal to this. whoa, is equal to this, right? And then I'm going to get this chunk of text that I have on top here, this, and test it out. It should work. Don't know, maybe, maybe not. Test. So it's a list comprehension that is problematic here. For what you know, it's just the word in, which is very stupid, is it? I think we're all tired here. So I'm going to come here, and I just go for var. No, but it's here. Okay, it's not here. It's here. For var token in. Let's see here. For var token in, I'm going to come back here. Var token, I'm going to come back to, not test, var token, var split, for var token in. Done. Okay, so we have a function now, right? And the way this function works, sorry, it took a while here, but the way this function works is if we feed it text, it's going to return the chunk of text which has been stemmed, right? Because you cannot stem the entire string. You have got to go into the string, you loop through it, word by word, token by token, word by word, I guess, term by term, and then you stem, and then you stitch it back together. So I've just created a very simple function that does this. And then what I can then do, right, is I can go to my data frame, yeah, which has this lower. So I can say, I'm going to overwrite what was previously supposed to be the stem here. And the way I'm going to overwrite this is I'm going to get the one that has been lowercase already, which is this, and then just do an apply. What is it? I apply my function which I've created, the fxn. I don't know if it's called fxn df stem or something like this. And it took a while here. If you notice when I was running it, dude, it's like it's taking a while. I don't know if you can see here. If I run it, I will time it if you wanted to. Yeah, it takes a while before you actually get to execute the entire chunk of code here, right? And the reason is simple. Remember that var records here has how many? 1,833 records. So what I'm essentially doing is, in all of these 1,833 records, for the title, for this title column here, I get the title column, okay, I get the title lower column, and then the entire text, right? Observe. Title lower, and then I'll just say iloc or something, 0 or something. So I'll get something like this, or I can get something like the very last one, -1. For each of these things, I'm getting this entire title for the dissertation, and then I unroll it, is it? I go into this, it's like I'm looping, using that this comprehension can use a loop, is it? If you want, I don't know. But you're looping through this string, right? In fact, what we are doing is this. It's like for var word in, what are we looping through? We are looping in this chunk of text dot split. Sorry about that. Dot split. We are saying we want to get each word. So each word in the title. But you see, a typical title will have a lot of words, right? So you get this word and then you stem it. You get this word, you stem it. You get this word, you stem it. You get this word, you stem it. So what I'm trying to say here is that if you wanted, you can create your function, your heuristic in such a way that you're not using list comprehensions, but you're using a for loop. That would be sad, really. But that's okay also. You can use a for loop, right? So instead of creating this function that I created here, colleagues, I don't know where the heuristic is here, but I created this. This is what worked, I think. This. So I've created this function, and all this function is doing is Format it properly here so that we see 1, 2, 3. Ooh, sorry about that. 1, 2, 3, 4. It's not even nice here, but that's okay. I could have done better. But all I'm doing here is I'm saying I'll get this string representing the title. When I get the string representing the title using this list comprehension, I am going to loop through the words in the string, and for each word that I'm looping in, I will stem it. When I stem the word, I reconcatenate them. Right? It's one of the reasons why I'm using this command. Well, I mean, if you want, you can create a 2 here. I don't know if we can do this though. Also, we can create. I think we can though. We can create a separate heuristic here 2, and then we'll say. Right? We're going to say. We get this string. We have this string here. When we get this string, we have got to split it somehow. Right? So you could say, for the word in here, boom. What I want to do for each particular word in here is I want to, guys, also, colleagues, 1, 2, 3, 4. I can say the final list or something is going to be an empty list or something like that. So for each word in the string, once split this, right? var underbar input split. What I want to do is I want to say, of course, I mean, I've already stemmed it, right? I have this Lancaster stemmer. You'd have to define it somewhere. I could, but maybe you can. The code here for this to work here, you'd have to do the usual import NLTK, and then you say from NLTK.stem, import everything or something like that, right? And then you'd say var underbar stemma Lancaster is going to be equal to Lancaster stem or something like that. I've forgotten the word here. It's like Lancaster stemma like that. So copy it here. Excuse me. I'm going to create an instance of Lancaster stemma like that, and then so that when I come here now in my for loop, I want to say I want to. I don't know, but I want to stem this, and when I stem this word, I add it to my list. So I can just do a var underbar. I can do this in one line here. Dot append, right? What am I appending? I'm going to append this dot stem. This is long also. Dot stem. What am I stemming? Var word here. Boom, like that. And then what do I do afterwards? Return this final list, like this. This is how this would work, the heuristic, ideally. So this function should be able to work just as well, right? I can do the test actually. So you see, maybe not the test here, but morphology or something. I don't know. I can do this as a test, is it? This entire chunk of text, we'll use this as a test. var sample title. And then what we'll do here is we'll call the function, right? vxn df stemma2, right? And then we're calling this with var sample title. So it works, right? So if you notice here, var underbar sample title is this actors and stuff, and then when we stem this using our function, actors has been stemmed to act, contributing has been stemmed to this, right? So in essence, what I'm trying to say is if you wanted, the way you'd implement this is you can use list comprehension, which I think is more elegant, like this, perhaps not very readable, or you can come up with an implementation similar to this or something like that. But what is important is you have got to recurse through everything in your data frame, in that particular series of the data frame, which is why we're using the apply function, ideally. I don't know if this is making sense here, but that's neither here nor there, I guess. So that's stemming, and then, of course, I mean, this stop word removal, easy stuff. If you remember, we had, I don't know how much of this you remember, but we had we had looked at this, right? We had said that with removing of stop weights, in fact, the removing of stop weights is similar to stemming, is it? Because if you are removing stop weights, the heuristic is simple. You get the chunk of text like this, var sample title, right? This. And then you check, is the word act a stop word? Okay? If it's a stop word, remove it. Is contributing a stop word? If it's a stop word, remove it. Is to a stop word? Yes, it is, by the way. Remove it. If it's not, you keep it. Right? So you notice here that you can either use list comprehension as well, or you can use like a for loop, ideally. Right? You can use a for loop. And the way that you'll be using a for loop really is, if you remember, the simplest thing to do, you have a lookup, is it? The lookup here is still, I don't know how much of this you remember here, but we had something like nltk.corpus, import stop words. Oops, stop words, like this, right? You're importing stop words. Words. And then I think I showcase something like this. So what you're doing is, it's a slightly bit thing involving here, but what you're doing is you're saying you're going to the heuristic here. For each title like this, you're going to check, is this word in here? If it is, remove it, right? Is this word in here? If it is, remove it. So you're essentially just kind of like you're filtering. You can use this comprehension, or if you want, you can again say we can use this fxn stop words. Remove stop word or something that's weird here, but var input, right? So you're saying if you have a input, if you have a chunk of text like this, how are you going to remove the stop words? Well, there's got to be a way of you looping through this chunk of text, right? So the way I would do this is I would say for var w in var underbar input dot split. So I split them, right? And then I'll check for each word, right? Like in here. For each word, like for actor here, I get actor, right? But this is horrible as well. So I'm just going to say get this like so. And then I'll just say var final list again. I'll just create a new list here. And I say for var w in var input split, I guess. Input split. All I'm doing, it's a simple heuristic here. 1, 2, 3, 4. 1, 2, 3, 4. All I'm doing is I'm saying if, yeah, if, but you see now, if this word here, var w, is there not in? I think this should be not in. Okay, I'm for var w, if var w, you know what I was trying to do here. If var w is a stop word, so if this thing is in here, boom. I'm gonna copy this. If this thing is in here, I'm just going to say pass. Else, what I'm going to do is I'm going to say var final list dot append. I'm just appending var w. If it's a stop word, don't do anything. If it's not a stop word, append it or something. And then what am I going to do here is I'm going to say the same thing we were returning, right? I'm going to say return. I guess this will work. I don't know. This dot join var final list, like so. Hope this works here. So if we can test this, right? We can test this with, and you notice here I'm recursing, by the way, records dot whatever, but we can test this, right? Var sample, something like that. sample title has A as a stop word, 2 and stuff. So if this works, fxn.remove stop word, and we feed it with var sample like this, it has removed all the stop words. A is not here, of is not here, 2 is not here, by is not here, in is not here. Simple stuff, right? You can use, if you want, you can also use list comprehension or something like that. But the key thing here is, if you notice, I'm doing this recursive visit. If I check my records here, right, I have var stem. So I'll get this thing that I've stemmed. In fact, I should have, before I stemmed, I should have removed stop words and that. It's okay also. But I can come here and I can say, I want to create title stop, so that I just have stop words. And the way I'm going to create this is I'll use the thing that I've stemmed here, like this. var underbar record, like so. And then again, I'm going to apply, right? So I'm just going to apply this using the fxn. I'm losing track of the names of the functions here. Fxn remove stop words like this. It's taking a while. If you notice here, it's still processing. Ooh, then done. It's taking a while here because this is slightly more involving. I'm doing a lookup here. It's brute force. So I'm looking up in this, right, which is computationally expensive also. And then if I check now var record columns, there's a new column that I've created, var stop. If I check var stop here, right, record var stop. In fact, maybe it would be nice if I compare this with what it doesn't matter here, I can check, but it does though. Title, stem, and this, right? Title, stem, not step, like this. What you notice is that, maybe this may not work here, but if I check, I don't know if I say ad hoc or something. If I compare the one that has not been removed stop words, right? This has been stemmed, right? Morphology, characteristic of is not here, if you notice. In fact, you can pretty much check by checking the length of the string or something like that. It will be different. So stop word removal, and then there's punctuations. I'm going to let you do this as an exercise, right? How do you remove punctuation? So in other words, how do you remove full colon, comma here must go, right? Say in the notebooks, I'll share them, but it'd be a nice way to exercise, right? You can use regular expressions if you want to. There's a way of removing punctuations using, I think using the string class or something. Okay, so you can do all those things if you want to. If this is making sense, I don't know. Yeah, so there you go. I guess typically there's yeah, I think so. You should be able to find the Python. There's a way in which you can actually extract. You can extract these punctuations ideally, right? Special characters is what you're doing, by the way. You're playing around with special characters. Playing around with special characters. String dot format template ask characters. There we go. Punctuation. So you work with something like this. That's it. So you can do a brute force kind of approach where this will be strange though. You're again looping. It's the same logic, right? You're looping through this, and then when you find this, right, you maybe replace it with an empty string, something like this. You replace it with an empty string. That's it, right? That's all. When you find a comma, right, if the character is in here, replace it with an empty string. Okay. Anyhow, deduplication we have discussed. Is missing values and stuff. Just to mention here that there's what is called domain-specific processing. You want to be wary of that. You see, if you're working with data that is from chemistry or physics, you know that the equations are going to have these special characters like caret symbols, so you want to be careful. with those things here, you know. The key thing here, the reason I have this slide is to emphasize this notion that this pre-processing of data is contextual, depends on the domain you're working in, ideally. Very, very important. So this is tied to text pre-processing. It's also tied to how you handle now values and all those things, right? It depends on the context, ideally. Okay, colleagues, I wanted to find out if there are any questions. At least we saved some of you, right? There were initially 20 or so people, but now we've thinned the head, but that's fine also. Okay, if there are no questions, oh yes, there's a question from Asta.
Yeah, just wanted to request for a loose end of the Google Classroom link. Since we got the email addresses for the department one to.
Oh, okay. Yeah, sure. Of course, I will. The Google Classroom link, I can resend it. But you want the code as well, or something? You want the link? You're already part of the class.
Yeah, I want to use the CS email and being part of the class.
Oh, okay. All right. Sure. I can resend it via email, but I've also sent it in the income messages just now. That's fine. I've just shared it in the income message. I think there was another hand up or something I saw, or maybe not. Yes.
When can we have this course added on Moodle? Some of us, we don't have it on Moodle.
Yeah, so the thing is, it's a manual process. And we're supposed to do this exercise together with the head of department, the acting head of department, Professor Piri. It's long overdue. But if it's any consolation, I think what is important for now, because the portal for the most part is usually linked to entering of final exam scores and stuff, right? I will find time. I'm committing to finding time so that I have people. And this is affecting all the programs, by the way. Our CICT doesn't have a way of automating this process. In fact, funny enough, the way the system is designed is students, once they enroll into courses, they can't unenroll, right? Or add other courses, replace them or something. It has got to be overridden by somebody with higher privileges. So I'll circulate a spreadsheet, and then I'll ask people to specify their courses so that we add them to your SIS. I'm committing to doing this before end of the week. So by Saturday actually, should have this done.
All right, thank you.
Yeah, sorry, the link is, I'm not being allowed.
So there's again another issue here. If you're using your CS account, unfortunately, the Google Classroom site was created using, and this is weird here, but an unza.zm account. So the cs.unza domain, the way it's configured at Unza is viewed as, what error are you getting?
Let me just get to it.
Are you able to send me your email address, and then I'll try and see if I can manually. If you click on join, it doesn't
your
work.
Account can't access this class. Switch the correct account class or contact your teacher.
Yeah. So just for now, as a workaround, you can use a generic Gmail account. I'll try and follow up again with Mr. Combo or something. He was looking into this. I see it was not resolved.
Okay, but the thing is, there's a course that I managed to join the classroom using the same Google Classroom.
Yes. So the reason you joined using your CS account, right?
Yes.
Yeah. So that course was probably created. Whoever created it with their CS account. So what I did myself is the thing. If you develop software, make sure that these functional requirements are taken into account here. I created this Google Classroom site using this, right? So the way this works, it views emails from the cs.unza.zm account as being outside of the domain, even though they share the main domain here.
Oh, okay.
Yeah. However, the other person you're talking about here probably created them. If I created this site with my cs.unza.zm account, this problem was not going to be there.
Okay.
Yeah. But for now, you can use your Gmail account or something.
All right.
All right. Are there any other thoughts or questions about this? If not, colleagues, we have a session that we have to make up for. I want to suggest Saturday or Sunday. Yes.
I don't know when exactly the Moodle issues are going to be tackled, but otherwise we are getting affected because some of the assessments are being posted on Moodle and we are missing out.
Can I ask, if you have a course representative for respective programs, can you have them reach out to me, and then what I can do is I can explain to the lecturers involved that there's this inconvenience and it's not your fault, right? It's an issue with the system ideally. Can I ask that we have your respective course representatives reach out to me? That would be easier, and then I can reach out to the courses. So just tell the course representative to specify the course lecturers involved, and then I'll follow up on your behalf.
All right, thank you, sir.
Yeah. If you can, well, I know it's late here, but if you can manage to have them reach out to me by tomorrow morning, that would actually be great, or help or something. All right. Thank you very much, everybody, and I'll be in touch. I want to suggest we didn't have there's a session that we missed out, not last week when apparently somebody died and they said we shouldn't have classes, but there's a session that we missed. So I wanted to I'd almost suggested that we have class over the weekend, but I've not been well. So I'm hoping that we can maybe do this interaction on what do you call this, over the weekend or something. But remember when we were talking about the test here, seeing as we finish this interaction, we want to say we've changed slightly here. So the test is going to be up to the lecture series that we've wrapped up today, because we are planning to have this test after next week, is during the study period. Okay. Thank you very much, and good night.